In our college, one of the important things is our focal point is our student. We are trying that all the students the purpose is again how we can technology in the automotive sector to our students. Here, for students, but we are also open this, central excellence because ANCIT, one industry professional also. Let's come together. I hope that everybody is taking advantage of this and we can give something more to the society. We can give one of the best way to the country. And with this information we are working, and I hope that everybody those who are present here is supporting us. Let's work together and that's the I think beginning of the day for me. Thank you very much for calling me here and thanks for NCT technology and for supporting our mind. Thank you.
Thank you, Mohan sir, for your this warm welcome and insight about this particular memory. I request Annamalai sir, brief organization and insight about this memory. Yeah, please start.
Hello, good morning, everyone. Dignity is on with Dr. Today, faculty members of JSPM Engineering College, my colleagues from ANCIT, a team from Electro Build, and other guests who have made it to this workshop conference. At the outset, I would like to extend a very hearty welcome to each and every one of you who spared your time to come and make yourself equipped in one more technology on automotive electronics. So, before we go into the conference, one of the things that we also wanted to start is with the signing of this MOU, and we are really passionate about this MOU signing with an institution. Today, we started ANCIT in the year 2007, and we started primarily as a 2B company, and all these years, almost like 17 years, we have been working with automotive electronics, we have worked with semiconductor industries, we have worked with tool service providers, we have worked with semiconductor industries like say Eon, Cypress Semiconductors, tools providers like EV. We work with tier ones like say Bosch, Conti, etc. We work with OEMs like say Mercedes-Benz, OEM, Mercedes-Benz, Volvo, and Mahindra. Today, but all these years we work exclusively in the automotive electronics industry, and we building on an option, building their organizations and their products. So in this context, if you look at it today, we are around 175 engineers. And if you look at all the 175 engineers, they are not engineers who have, like, say, if you look 90% of them, 90% of them, all of them were groomed from their college days to ANCIT. So all these engineers joined ANCIT as a fresh engineering grad, and today they work as our team in different organizations that we mentioned. Everybody supported and groomed in our own organization. So we don't usually, like, say, take this, but we believe in building a strong community rather than, like, say, trying to just create businesses and without value proposition to the society. So in this sense, from 2018, we started a new firm, which is also called as ANCIT Techday, where we started working closely with many industries doing corporate training. We also work with many colleges signing MOUs. We call it as which is focused on research. And one of these MOUs we are happy to sign today with your prestigious institution. So I'm really happy and glad that we are able to make it today and today. And thank you so much for the faculty members, and thank you so much to all who made it to this event to witness this training. Thank you so much for making it, sir. It is a pleasure and honor to have a sign with your team. And I think also you should give us other institutions an opportunity, not taking all the words for yourself. Give some opportunities for other institutions as well. All right. On a lighter note, once again, I take this opportunity to thank each and every one of the faculty and the students of JSPM who have made it to this institution. And let's complete the official signing of the MOU. But one thing that we can assure you from ANCIT team is we have signed MOU with many. If you look at the feedback, we have actually gone, our engineers have gone and spent at least 2 to 3 months of their time in helping your engineering to always we don't believe in signing MOUs and leaving the rest. We will make there is definitely a lot of value that gets translated to the students so they come back to the industry. I now welcome the members of the institutions and our CEO, Mr. Anand, to sign this MOU and take this discussion forward.
Zoom link is the personal password.
அந்த பிள்ளை ஐடியில போனா அந்த பிள்ளை பேர் தான் ஆயிட்டேன் நம்ம பேர் அப்பா
அந்த பிள்ளை ஐடியில போடலாம் நம்ம அது மீட்டிங் ஐடி
Thank you very much, sir. Just one minute. I request in the Dean International Relations, Dr. Rao Bole, to propose vote of thanks.
Namaskar, Team ANCIT, the leadership of ANCIT, all the guests from industry, and the faculty members and students. Before I give my vote of thanks officially, because we will be leaving, we need to be there in other place to our prestigious award, as Jain sir was mentioning. For industry partners, 2-3 lines from our side. Being an autonomous college, we run a curriculum which could be customized as per the industry requirement. So whatever job role, job description, and the skill set required, we can accommodate them in part of curriculum, be it theory or practical. Last 6 months, we released our candidates full time at the industry side. And today the talk is all about automobile. So we are closely working with Blue Binary, KPIT, as of now from this area. And other companies definitely are there, like from IT side, Veritas, TCS, Capgemini, etc. So I appeal all the industry partners, whomsoever are sitting here, we can work closely and we can deliver a resource who is deployable on the project from the first day of his journey in the organization. So Team ANCIT, we are very, very thankful and eager to receive you tomorrow on your campus, our campus. And let's hope we will have a great experience working together. And going ahead, you were apprehensive about other organizations coming to our campus. As Jain sir promised you, we are always open and open-minded. So we are ready to have people coming from outside and taking that experience what you are giving to them. So thank you, Jai Hind. God bless you.
Officially, today's inaugural function as well as the signing function is over. So we can see the next activity, which is as per the schedule.
Hold. Sit.
Hello. Yeah. So once again, I'm back. So officially, I would like to welcome you all to the Automotive Tech Day. So the Automotive Tech Day is an event that ANCIT organizes every quarter, and this is the first offline Automotive Tech Day that we have organized as an organization. So the objective of this particular Automotive Tech Day is to bring in the best speakers, not in India, but across the globe, and deliver something extraordinary on automotive electronics that engineers could be using on a day-to-day basis. There are 500 engineers who are watching this program online at the moment. And there is also, today we have an extremely knowledgeable speakers who are some of the best in their field who are going to address this gathering in this conference. So on this note, I would like to again take this opportunity to welcome all the members to our Automotive Tech Day. The first speaker for today is Mr. Colin Dong, Technical Manager at Tosun. Tosun is a company that we've been working with for quite some time. They make some great engineering products. They work exclusively on the test and measure. They work extensively on the test and measuring techniques in they have a very specialized tool called the Tosun hardware, which is responsible for capturing information on canvas. And right now, they are also expanding their scope into the Ethernet stack. Right now, we have Mr. Gordon Gong from Tosun, who's a technical manager at Tosun, who has a wide experience in working in CAD to address this. He's going to talk to us on the topic of UDS flashing, something every automotive industry has to be aware of when they have to put their ECU into production mode. Over to you, Mr. Gordon Gong. Thanks for having you. It's a pleasure to host you today. And over to you.
Hi, Colin.
Yeah, hello. Good morning, everyone. Yeah, I'm Colin. Maybe I will share my screen now. Yeah,
Colin, can you share your screen?
yeah, okay. Everyone can see my screen now.
Yes.
Okay, thank you. Thank you for ANCIT having us for today. We truly appreciate your efforts for holding this technical events. And good morning, everyone. Before we start, let me introduce myself briefly. I'm Colin, technical support manager from Tucson, China. Yeah. And today I'm going to talking about a UDS flation solution with the TS Master. As we can see, first I will introduce our company. At first, TS Tucson Technical was launched 2007 and specializes in automotive electronic industry with a focus on providing two-chain products development. As we can see, we focus on the lean CAN, CAN-FT.
Colin, can you hold for a minute?
Okay, great. Yep. Yep, I'm listening.
Please hold on for a moment. Just trying to fix the audio in the auditorium.
Okay, great.
Yeah. Hello, Colin. Can you start speaking, please?
Okay, thank you. Okay, now I continue. Let me introduce to some technical a little. As we can see it, we was launched in 2000, it's 17, and
Sorry, please hold on, Colin. There is some challenge. Just give me 2 minutes, please. I'm really sorry.
Okay, great. Yeah.
Hello,
Yeah,
Colin.
yeah, I'm here.
Can you speak now?
Yeah, I can. Yeah.
Yeah. Perfect.
Okay. Okay. So, may I continue?
Yes. Yes, you can continue. Thank
Okay.
you.
Okay, great. Thank you. Thank you, everyone. Just a little bit, like for a moment. As we can see, I just introduced our TS Master. As we can see, TS Master software as the Tucson core software. We can see now TS Master can support a lot of hardware, and we can see left side as the software platform using the Corner API. As the upside, we can, as we can see, we can using the different functions like testing, calibration, diagnostic, code generation, app, and so on. For the upside, left side, we can see we can support different hardware. For example, CAN, CAN-FD, LIN, FlashArray, and Ethernet, and so on if the I/O cars and the chassis and cabins instruments. Yeah. And as we can see now, for this program, TS Master can integrate with the C, as we can see, C# and C++ as the Tucson mini program. And then we can also support many platforms. Basically, it's the nesting function. For example, we may call the MATLAB capsing or Canute from TS Master as well, as for example. You may also have the MI device or even some Keysight or, for example, different scopes. And also, we can support different other brands can in another device using NTS Master. As we can see, let's go to Tucson KNFD device. There are some different products. As we can see, if you just using one channel CAN, we can also support, for example, full channel KNFD and have two link channel. And as we can focus more, as we can see, we can support even 12 CAN-FD to USB. And we have a different type, for example, mini PCI or PCIe. And we can using the 2-log to load using the offline logging. And we can also using some, for example, have the Wi-Fi to CAN-FD and have the some CAN-FD CAN gateway. And as we can see, CAN-FD to Automotive Ethernet, we also just as loose route. And for another hardware for TTS testing system, using for the automotive control system to carry out comprehensive and in-depth function testing, fault testing, bus diagnostic testing, automation testing needs. And in this TTS include digital I/O, analog I/O, power supply, fault insertion card, and programmer switch and resistor. If you have any other needs, we can have the customized solution. It is for TTS hardware using in TS Master. Let's continue. For here is the some value functions for TS Master. As we can see, for the first one, and also it's today's topic for UDS diagnostic, and also not just for this function. As we can see, TS Master can also support CCP, SCP calibration, and RBS, it means remaining bus simulation. Also support TS testing system. And if you want to do some data traffic analyzer and logging and playback. For code function in TS Master, we have the C script and Python editor. We can add our script and running in TS Master. Yep. And so on. We can also support other like DBC, LDF, SML, MPDU, ARTM files into the TS Master. Now, let's continue. For here, it is the TS Master flashing. As we can see it, for first state, let's see it. At the first state, TS Master can configure the flash process float, and we can download the config file into, for example, we have the TF1011 to download, and then we can flash the ECU offline. Yep. And as we can see, this third state connect to the card and start running. It is for the ECU flash tooth. And also, it is, if we're using the CAN-FD to USB, we can using the laptop or PC with the CAN-FD USB to refresh the ECU, for example. Yeah. And now I will introduce the key features today. TS Master UDS. Yeah, UDS features. As we can see it, the first state, I will introduce the transport layer, ISO-TP. If we open the TS Master software and with the diagnostic, we can support CAN, CAN-FD, LIN, Ethernet, UDS download. And if we want to select a different layer channel, we can also add a different request response ID and type. And something, if we're using the CAN-FD, we can also to setting the CAN-FD maximum DLC, and for the, as we can see, it is a BRS. If we want to set the maximum length of service layer package, we can also change for any other configuration. And second, we can see at the start, we can setting the P2 time, for example, maybe the P2 timeout and instant. And for the S3 server time and client time, we can also select before we start the float. And the another features, as we can see, is the CN-kit. Maybe we can using a demo later to show these key features, how to run in the C-kit. For example, we can support load the deal file, and the second method, we can using the source code to run in the C-kit. It is another key features. And that is just look through. We can support some source code function. As we can see, it is the general key it's very normal functions to using. And then we can using different type and so on. And if you have some customer C script, for example, we can also to support. And after that, we have the C-kit tester to check what it's run and write in the deal file or source code with the generation. And then we can go to the basic diagnostic configuration. As we can see it, we can create multi-diagnostic service. For example, we can see for first is the 10th service for diagnostic session control. And if we're using the 22 is the read data by ID. We can also create another service with the different requests and response. We can see the right side. we can get a request and get a response. We can do any settings in it. And here is a key features. We can see resistant diagnostic series as system variable for instant automation codes. And here is the key features. Maybe later I will introduce for TS Master software. And then we can also support some other files, signal files, or if customer have the data formats for enterprise using, we can also to support. And then we will go to the generating for, as we can see, it's the download file, it's the download file, it's the combined service. As we can see now, we have support, test file, bin file, S19 mode, and if we have some customer file, we can also support. And then we can see, we can change device start address and data length, and can change to check some byte old, maybe using the Intel or Motorola. And if you're using the different CRC, we can create a new CRC algorithm and have the download file viewed after we input download file into TS Master. And now here are some details. If we're using the download file, there are some sessions we can configure it. As we can see, if we want to download the file, maybe we need to erase flash. So normally we have no automatic erase, and we have another two tries: foot erase and block erase. If block erase, it means erase every block before we download. And that we can go to the request and transmit data. As we can see it, we can change the maximum transfer block length. For example, if we set it at 202, it means the actual transport layer data package will be 514 bytes. Here is some tracer from the UDS download, as we can see it. And after that, maybe we're using the translate exit. We need to some, as we can see, we need to some checking sound or block checking sound. We're using the 37 and with the 31 service, we can change different settings. Maybe sometimes here is not checking, or we can using block with the ECU and on PC. And maybe here is the more details we also showing in TS Master software. And that here is the diagnostic controller. After settings, we have already configuration. We can use the controller to running every service before we download or we need to check. So as we can see it, compressed actual response, we can using enabled and off-enabled. And also we can see it, it is the Windows, we can see ISO the trace. If you running the UDS download, you can monitor the transmission, the data package, and parameter processing. Yeah, and that here is the more key features in TS Master. If we're using the UDS features, it is the automatic diagnostic. We can add a lot of the float if we want to flash in the ECU. Here is an example. As maybe we can just look through here. Maybe we will start. It is the extension sections, and then start and maybe read some data, close DTC, disabled RS, and then we need to go to the session it is the program session. We will using the CN kit and using the flash file. Here is the erase flash. It is the app demo hex file. After the download the hex file, we may be using the ECU erased and then enable the IS and read it. Here just the very simple example to download UDS file. In TS Master, it's very quickly to add this float without any source code. We don't need to programming, just using our mouse, then select a different service. How to running? We just using one button. Here is the one button. Maybe later I can show this function running to this download if we connect to the ECU. Here just is the float compared to the TS master float. It's very similar. If just something like we change different ECU, maybe just some float or some service change. We just change using different service in here. After that, if we have already configured a float, but we can also using the system variable to enable. For example, if we want to running this float, we can use in just one button. Here, oh sorry, here is the Chinese, it means the start. We're using this button to start. It means we will start with this float. So maybe sometimes we just using the panel to flashing different ECU. For here, we can select different ECU to adding another hash file and deal file in here, and to start just using one panel. We do not need we don't need to see any other UDS flow in here. We're just using this plant because we're using the simple variable to connect to these different panels controller. And here we can also using the some C-script if we want to using the testing system in test master. Just here example, if we have using the diagnostic default session start, we're using the setting session variable to 1, it will start this service, and so on. It is using the test master testing system and C-script. After that, we can also support importing the ODS file and PDS file diagnostic database. So we can input and that to control and to see different diagnostic service. And now maybe should I change my computer into TS master as a UDS demo? Yep. I'm here. I have opened and TS master. In here, just look through. As we can see, let's go back to the TS master diagnostic function. In here is the first state. Maybe we can select. TS master have already support CAN, CAN-FD, linked, and Ethernet. Maybe for the Ethernet, we can also support the dual OIP, sorry. And then we can select a different type in here and so on. Maybe we can more focus on the diagnostic layer because we have here have the CN kit, deal file and code. In here, I just running as the CN key editor. For this CN key editor, it's very quickly to edit. If we select a different function, we just to agent in here, okay, and then it will combine. We're using the check for here. Maybe here is the label 1 as the general kit we have the seed and then get the kit. Because here is example, so we can see every byte 8 in the 8. Because we can see go back to the here just 8. So if we have a different algorithm, we can change in here. And that we can also support different using the DIL file type. If we it's really normal to using the DIL file. But here we can also generate a DIL file. If we using the a DIL file, maybe sometimes we need to send DIL file to our customer or to other person to using this DIL file. But yet, and let's go back to the basic diagnostic configuration. Here is the demo. As we can see, it is the 10 service. How to create a new service? We just add a new service. For here, for example, after we just select, here is the new, totally new. We can see we got the request and response. Because for the diagnostic session control, we can using the select. Just using this button, we just select. Maybe it's the default, and then it's the programming and the extent, and so on. Maybe we just select. For example, is go to the default session in here, how to running, and then we will go to the consoler. Maybe we notice the NAND is the 10. Go here. Also, we get the 10 right here. How to running? We just using the execute. Maybe I just check, and then we will send out this message with the 10 service, and we got a 15 response in here. Now, because I have connecting a virtual ECU, so we got a positive response in here. So let's go back here. It's the 10. I think here is another key features we'll introduce because we're using the system variable. As an example, for 22, read the ID. We more focus on the response. When we send out the 22, we will get back 62 as the response. And now we can get different SS. For here, we have the parameter to encode the different data. For now, here is the read parameters we can set. So here example, we're using the system variable in here. For example, we have already create from here as connect. It's the string type. Also, we can connect to different type in here. Here is an example. I also running this service as an example in here. We can select to 22 running to execute. And here we see the result. We send the request and get a response. If we know any other in here, if no any other parameters, we just see the row value in here. But if we're using the parameters, okay, we got the 2 response from the ECU and have already encoded. In fact, it's the ASCII code valued in here, and it is the 48 from here. It is the because the hash value into the 48. Here is the one key features. Another key features I will introduce is the combined service. It's the download file in here. For example, I have already created another, and then I will go back here. Maybe it's the configuration. Yeah, let's go back here. I have already imported hash file in here. We can see the different block. Here is the full block. The first choice we can see if we want to download this hash file, but I have another choice. I do not want to download this block, just disabled, and so on. We just using the different enabled. And for here, we can see is the route, and then we can change the checksum for here. We can select, and if we're using the user defined, we can add our user defined in here and then to run it. and so on. We can select Intel and Motorola. Let's go to the erase flash. Maybe the PowerPoint have already showed in here. I just using the demo to show these functions. Maybe for here, I have already go to the download console as an example. Let's go here. I also execute because I using the virtual ECU, so I can run every single service as the running. Let's go back to see the tracer. We can see here, we got the block erase every block. So we can see it will start every first 31. It means the erase. We can see because we have 4 blocks, we can find here is the 31 series. Here is the first one, and then after that is the second one, and third one, and fourth one. So because I have already selected the every block. For example, I do not using the auto erase compared to the trace. I just running again. As we can see it, here's no more 31. As we can see, look, start. It's totally you start with the 34, no 131, because we just select the no auto erase. And if we're using a 4, only 1, and so on. Let's go to the request and transmit data. In here, as we can see, it's using for the 34. In here, it's the 0 because I set in 0, and we got the request the here it means, yep, it's the 202. We can change. For example, I just using the 1000 as for example, and running again. Just quickly list through. Yep, as we can see, we have already changed the every service package into the 4096 because I have already changed. And then let's go to the transmit exit. In here, we can see more focus on the 37. Here is the check every 37. Let's go back. In here, we can see 37 with the checksum value in here. We can also change, for example, I do not need any check, and run again. It's very quickly to running and get the result. So we can see more focus on no more checksum in here. And also, we can using the 31, for example, in here, because maybe we want to using the block checksum with the 31 service. In this flow, we do not see any 31. Let's check again. It's really quickly to running. As we can see, we got every, okay, here is, I need to check is the 1 and run again. We might get 4 here. So we can see every get respond, we will start with the 31 because we're using the checksum in here with our configuration. After that, we can also support other file in here. And here, another features to support. If we're using deflection, I have already input this hex file. Let's more focus on the first block. We can see the first block have the, yes, is 25,000, yep, almost length. We can't split it. For example, I just using 1,000. As we can see, here's the result. We can split it flash block with the maybe we need to do some configure. After that, we can enable and disable every block, for example. And here is another features. as an example, maybe for the first state, first block, the start address is the 83. We can, using the mapping address, just using the mapping address in here. For example, I just select in here, I just check. I will start with the tooth. Just only with an example, more focus on the first block and go to the tracer and try to download. We will more focus on the first block. Yep. In here, have already changed. It is the start address. Here is the start address. Have already changed to 20. In here, no more 0. So it's more flexible to configure our diagnostic download. If we have any other configuration, just using the TS master to select on settings. After that, we will go to the automotive diagnostic. It's the more key features in TS master because we just using console to check every service, run and write to get the response. But we using the automatic diagnostic to download ovulation ECU with one button. And here is the demo. We're using this demo. We have already seen in the PowerPoint before, but I just very quickly to operation. For here, it's easy to configuration. Only 4 state. We can see we're using no mode or using the select. Maybe I will go to another totally empty service in here. For example, is the normal emptied. In here, we can using the select. For example, we can select the here is the totally tent before we have already added. We can just adding in here. Also, we can drag and drop in here and to select a different float in here. Okay, let's go back to the demo. How to run this demo in here? Maybe I can using this button. After we have already created, we can just using the one button to download the ECU. And we can see is the tracer we downloaded flash.
Hi, Colin.
Hello, he got disconnect.
Okay.
He's connecting right now. It's saying reconnecting.
Okay, sorry, maybe some connecting problem. Everyone can see my screen now.
Yep.
Yes.
Okay. Okay, great. Thank you. Yep. Maybe I just continue in here. I will go back to the automatic diagnostic as this demo. In here, we can use one button to flash the ECU. Another key features in here, we can't resist the system variable in here. So using this system variable, after that, we can go back to and so on. I'm using the TS master in here. Programmed system variable. In system variable, we can see it in here. We got a lot of diagnostic system variable in here. For example, I've just one demo one. It will create a demo one start and result. And here is the description. After that, we can see it. We using the start with the any more than 0 will start this float. So we can using this system variable in panel. So I go back to the panel. I using this button to connect to this float. As we can see it, I just using this button to start. For example, I totally using the panel to start the UDS float to flash the ECU and so on, because TS master support the C script and Python script, and also can use in the COM series. So if you have the MATLAB or another C script service, also can use in this system variable to start the UDS float. So if we want to using another automatic service, we just using this system variable. And that, let's go back to here. We also can create any other system variable. So we can see here, we can use this one button in here. For example, using this one button to send out this service is totally, for example, we can start. It's the one key features in TS master. It's the UDS solution. And let's go back. We can support DB. In DynosDB, we can see in here, just stop the translator. In here, we can support ODS and PDS file in here. After that, we can input and select the different variant, MCU, and so on for the TS master UDS features in here. And for here, it's totally for UDS download with the UDS float. And here is another features we want to introduce. Here is the example. For example, I just running and want to run this float. Okay, I just using this service. Okay. Continue. Maybe sometimes just stop as running again. We can see it after we send out this request and get the wrong response, and then this float will stop in here. But normally we want to continue, or sometimes we want to retreat another time, for example, 1 and 2, and then we can select to continue. Because I have already get okay, it's the wrong response do not include our this. So we can something continue to this service as the UDS features. So it is the TS master dynasty. And as we can see, in TS master have another key features, but to date, I just more focus on UDS, just one buttons in here. We have got the C script and Python script to setting another sessions in here. So today I just more focus on the UDS, and with the sound analyzer, we can using the tracer. So if we want to focus on the UDS download tracer in here, let's go back, just running again a little bit in here. As we can see, go back here. I just running, and we can using the tracer to see raw data in here, and using the start and logging to load every tracers. If maybe sometimes it got some wrong requires a respond in here, we can get a raw trace and doing the analyzer something like that. Yep. So I think here is a lot of functions we will more interesting to show, but today I just to show the UDS with the TS master, because the TS master is very powerful tools, and I just using this demo to show some key features in here to introduce these TS master features to date. And I think my thank you everyone, my introduce in here, and thank you everyone for your time and to show our solution to some solutions, and appreciate your time. Thank you.
Thank you. Hello. Thank you, Colin. Thank you so much for the very interesting and entertaining session on how we could take UDS and do the flashing. It was pretty interesting. One quick question, Colin, out of curiosity, do you also have features where we try to change the sequence of UDS flashing? Is it does the tool provide this service, the flashing sequence?
Yeah.
Okay.
Yeah. Yes. Totally. We can change different UDS float. We can configure different UDS float. Just change the float and the running. Yeah.
Thanks, Colin. Thank you so much for this time for the day. At a time where this buzzword in automotive today is SDV. Every automotive car maker has his own definition of SDV, and every automotive tier one has their own definitions of SDV. So today we have a speaker in our midst who's going to bust this myth, and he's done a lot of research working with different OEMs and different tier ones. He's also worked with, he's visited numerous institutions and tried to understand his perspective of OEMs, tier ones, and even other service companies. And here he is to present a collective information on what SDV for as a future holds for us. I am happy to invite Mr. Janagraman Vasudevan, founder of Cream Color, to share his experience on how to approach SDV as a technology from an engineer perspective. So Mr. Janagiraman Vasudevan has a rich experience in data analytics, and he's also a full stack developer. Thank you so much for coming, sir. It's over to you. Yeah, I think. So how do we do this? Will this be streamed? Yeah. We can. I can take in Zoom always. Yeah, we share the screen in Zoom. You speak here, sure. And then you keep that. You keep the laptop. Yeah, you can stand here. No? You can use the podium. That nobody is sitting. No, so I can just plug this. No, nothing to do. Connect to Zoom.
This one had to be open. Cost of insurance is very high. Yeah, it is showing about 3 months. Are you able to hear me? Let's get started. So, good morning, everyone. As Patrick is explaining, so we are a startup. Okay, so I come from a technology background and consulting data analytics, full stack experience of 15 years. And then now we came here with the startup last 1.5 years to go through the journey in the software defined industry, right? So automotive is really becoming a software defined industry these days.
Mr. Jana, sorry, there is an echo which is coming from your end. Is there a problem?
Is this fine now? Are you able to hear me clearly now?
No. It appears that your voice is coming from a faraway place.
Just give me a
Am I loud and clear? Is it clear now?
Perfect.
Hello?
Yes, you are audible.
Hello?
Go ahead.
Yes,
Yeah,
you are audible.
So we don't need mic. So you need a mic for this one, yes. We don't need that mic. Use that mic. No? We don't need that mic. It's working. I can keep the other job. Nothing, sir. Am I audible?
Yes, perfect. Loud and clear.
Loud and clear, huh? Okay,
Yes.
thank you.
Am I audible now, Narayanan?
Yes, please. Clear.
Please confirm once again.
Clear, very clear.
Thank you so much. Yes, so we are a startup, software-defined vehicle based competencies and career research is what our focus is all about. And I am here, as Karthik was saying, the SDV is a real buzzword, especially in the last 6 months we are observing, though we are observing this topic for the last 18 months. Now, last 6 months we see SDV definition is really booming everywhere beyond autonomous electric and autonomous are already a known trend for everybody, right? So now let's understand what is SDV and what it is not. Is it like electric vehicles? Is it going to do some contribution to reduce some accidents, or it is going to contribute in terms of reducing the fossil fuel consumption? So where it is going to contribute, right? So how it is becoming a trend? Why? Which factor is driving it to becoming a trend, right? So that's something we have to understand. So that's a crux of this talk, and I'm not going to get into the tools, technologies, much detail, at least in this talk. Let's understand what is SDV overall, and then it is still at an early stage. Okay, so then we have still a lot more months to come, years to come to master that and then go further, right? So the evolution of the ecosystem is still happening there. Right. So let me quickly move on to news from Renault last. Uh, it will move then. Okay. Right. Yeah, it is connected. Just couldn't. No, 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 no. Okay, just- Yeah, I understand. In here, but the direction.
This thing. Yeah.
Yes, the slide. You will see.
It's changing.
Yes, it is changing.
Hey, sorry. Yeah.
Sorry, there are some glitches here in the connectivity. Yeah, let's jump into the stats, right? So this is like by 2030, with the overall market value of automotive industry globally, we are expecting it to be 5.5 trillion, right? So from 3.3 trillion right now, where we are today, to 5.5 trillion, we are expecting as the growth. And in that, today the software market in automotive industry is all about $280 billion, right? So, which is increasing it to $1.2 trillion in just other 7 years, right? So this is going to be a staggering number, and where this market is going to grow, through which innovation streams are kind of customer use cases that this market is going to grow. That's more important to watch, right? So yes, we already have a leading trends like EV, connected vehicles, autonomous vehicles, where we need a lot of software. But this software-defined product engineering is definitely one of the important driver in kind of changing this, because the way we do engineering in automotive is fundamentally getting changed. So it will also get percolated into the component suppliers and others as well after I think 3 to 5 years from now, right? So right now the change is already kind of acknowledged, and companies at the OEM level, tier 1 level, and system integrators level, they are all working closely to adapt this change and how to really get their organization, workforce, and everybody aligned with this change, right? So that's something which we will go in deeper now. So this is the news, right? The last April, this news, if you are automotive industry follower, so this news is a big news, because Renault Nissan was announcing SDV they are going to launch in 2026, and for that they have established a partnership with Google and Qualcomm, which is very big, and there is also one more Indian player who is in the key partnership, which is KP80, right? So which is good for India as well. It's not only Google and Qualcomm for the chips, and Google for their entire cloud or Android and those kind of ecosystems and connectivity use cases for SDV, right? So, but KP80 is also there in that, and definitely other cloud providers are also there. The most important part is Google and Qualcomm. Right? So, what's happening yesterday? I was in a conference where there is some gentleman was saying that uh, Qualcomm and Nvidia, they are all coming from the south, whereas Microsoft, Google are coming from the north, and they are trying to merge, or they are trying to go to the other end of the pole, right? So they are trying from hardware industry to go towards business application services industry now, okay, to get the customer oriented connect and user applications, which are custom SOCs and applications that they can give by building a lot of connect with applications, whereas the Amazons and Googles are coming towards hardware integration, middleware, where they are working closely with the hardware. And even in that, for that matter, if you see OpenAI founder, right? So he was also kind of his next company was pitching for multi-trillion dollars around chip manufacturing, right? Chip design through AI, right? So this says a story where people who are doing AI applications and all those things, they also feel the need of connecting to the SOCs and underlying hardware where embedded AI and ML is getting played. So they can have a very clear and deep insights they can give without limiting themselves to the hardware kind of limitations with respect to devices. and they can also scale bigger, right? So that the domain needs are really bigger now. We need to understand the customer much closer to the finer point so that we can personalize everything for them. We can't be very general, very broad, how we were in the last 10-15 years, where technology is good. But now technology, which is personalized, is what is needed to stay in the market for every business today, right? So this I just want to get this news. So this is real. This is not the businesses are already started and they are working on the partnerships and the SDV vehicles are on the way, right? So let's understand. Let's go back a bit more on the fundamentals, right? So we say SDV, but SDV itself is uh, a kind of automotive version of software defined product engineering. That's how we say from our end, what we understood SDV is all about. It is nothing but digital product engineering or software defined data driven product engineering is the core of SDV, right? So to deliver the software features more in a data driven manner, how the customer want and how quickly you can deliver. If you are in a software industry or if you are familiar with software industry trends in the last 10 years, so and startups especially, right? So how many of you are here and related to startups? Good. So you know the speed of delivery in the startup, right? So you need to ship the software, ship the kind of features so fast in agile, DevOps, whatever it is, right? So this was in the software-based companies. This was a norm. Without that, you cannot survive and then come out, right? So that's a kind of area now automotive industry is also kind of venturing into, and let's see in that perspective how driving there are multiple core functions of a vehicle, right? So driving, power generation through a fuel, and then reduction of power losses, comfort and convenience, safety and security. These are all overall there. These domains were there. I think last 100 years we are evolving over these domains with different applications in different segments for different geography, different kind of usage, right? So that's all we were doing. So what's there to innovate here further, right? So we because transportation is inevitable and we have to use it at every level, right? So whether it is a two-wheeler or four-wheeler or commercial vehicles in which or a train or anything, right? Or flying taxis, whatever you call, it is inevitable. Multimodal mobility, even if it is coming, we have to see the mobility in this aspect, okay? Because as much as mobile carriers carry human beings, safety and security, comfort and convenience is must, right? So the regulations and the compliances for the regulations has to be taken care in all these aspects. So let's see this driving, right? So driving has, if I just try to break down, okay, how we were driving before even ADAS autonomous features are also there. Some of these items, some of these areas, right? Like during the drive, how will you do the drive decision? So detection of some obstacle or somebody coming our way or signal is on. It's all human was doing. Now slowly we are trying to also get the support of the machine, right? So let's say ADAS and other things. And driving assistants were there still. There were boards. There were passenger sitting next to you. Okay, so there were FM and other things where traffic congestions have been told, don't go that side and all those things. And so that was all there. Then later it was Google Maps slowly. Then now we are going towards generative 3D maps, right? So which is available now at real time by seeing the traffic conditions and also the kind of a speed that you are going, the pedestrian movements, connecting to the infrastructure, they are able to bring the 3D generative maps. That's what now autonomous vehicles are also kind of aiming to use to somehow sustain their business and then somehow make it as a reality, right? So yes, we will one day it will become reality. There are hard efforts going on every end, right? So there are robot taxis, full autonomous vehicles. Everybody is trying out there. So this automation is going to be continuous. This driving automation, whether they start from an ignition perspective, it is automated. Now, if you go and sit there, keyless ignition they are able to bring, right? And movement controls, acceleration, deceleration, everything, cruise control, it's already there, right? So it knows if you are in the highway, then okay, this much acceleration and all those things were there. So individually each items were kind of automated. Then together things were automated. They are trying to remove wherever human in loop. They are trying to slowly get them out, right? That's how software do. That's how data do, right? So it tries to automate and then see how we can apply technology and reduce the human work out there. So that's what we did in every equipment you see here, right? From industrial revolution till now in the knowledge economy. So that's going to happen. This entire automation is called driving innovation, and this is autonomous vehicles. That's what they are trying to deliver: level 1, level 2, level 3, level 4, level 5. So that's so that we have available with us now. So then that's other innovation stream that everybody want to work, right? So now with ICE engine, the efficiencies are 99.99. They are just making more and more efficient, right? So with the electric vehicle, there are still a lot of rooms, whether it is battery electric vehicle or ethanol or anything, right? So it is hybrid, CNG, whatever you say, there is a lot of room yet, and we have a lot to play there as a business. And if we are really able to reduce the fossil fuel through the electric vehicle, uh, by using the grid electricity also coming from green energy, then it makes sense a lot. But still, we are there. We have a lot to do in those areas, because electric vehicle cannot succeed in contributing to the environment only with the vehicle. We need to see the entire value chain, right? How it contributes. So I think safety, security, comfort, convenience, everything will be related to these two, and that's where connected vehicles, shared vehicles, all those things will be there. So let me now get into for now, before I move from this slide, each and every item here listed in the bullets are functions of a vehicles, small functions of the vehicle. Let's carry like that. So now, how can we make these functions software defined? That's more important. So software in vehicle was always there, right? We were writing program in C++, in Android, in Java, in the vehicle for I think last 15 years. I think autos are when they introduced itself, then there were a lot of programming going into that, right? So that consortium was trying to also bring in multiple side from middleware applications, right? Every side programming was there, whether it is embedded program or application specific programming was there. But where the software is now coming, before it is about connectedness, right? So how you today, if I am giving a feature for ignition, that after I come sit in my driver's seat, it detects my face and then start the vehicle. Okay, let's say that is a feature. And now I see that, okay, somebody can put my image out there and then make the vehicle start. So this feature has to get updated. Otherwise, I have to change the vehicle. I have to change the part. Otherwise, I have to get it to dealer again to do all those things. If we need to wait for making 100% ready product, like how we were doing in automotive these many days, right? So we were having perfection as our goal. and we want a perfectly safe, highly regulated vehicle which matches every specification in the requirement, right? That's how we were delivering. Now that is not possible with all these new features. You have to release, then only we know whether the customer wants it, because customers are buying the vehicle not for your tire pressure or a tire your wheelbase or for your engine horsepower. Now they are buying the vehicle for user experience, comfort, convenience, right? So connectedness and all those things. So this is something, if we need to deliver features for them in that sense, it has to be connected, it has to be frequent shipping of new features. That's more important. So the software has to be defined by the data that we acquire continuously, and it has to be driven. It's not only from the vehicle, but also what testing we have done, what other vehicles are, where that same models are failing in other scenarios. The continuous learning from the cloud, from your own vehicles or vehicle fleet or that particular brand, everywhere it has to come through that learning process. And that's when it becomes data driven. And that's when your new updates make sense, and new updates are continuous and getting shipped to the right persona, okay, who can use that in the right way, right? So that also we can prioritize. So this is very important feature. The over there update features in mobile is very different from technically both are same, but from a usage and impact perspective, automotive over there update can be more impactful because it has more layers. Okay, so it's not only at the app layer, you can update at the middleware layer, you can bring in more different apps. So for example, the infotainment or digital cockpit oriented apps are just view and engage, or less issues you will get in terms of safety. But if you go to a robotics applications in ADAS, right, it can kind of handle mechanical and electronics functions also, right? So that is where the challenge on this apps area. Just, I think I will just get the charger. With lot of hurdles, the software-defined vehicle trend is coming to the market. So like that, we have to also do this presentation with a lot of hurdles, right? So yeah. So now let's move on to the over there updates we have seen. Then what is this E layer, right? So electrical electronics layer were also there before. What's changing now? Okay, so electrical electronics layer before was more through wires, CAN protocol, and it is more safe, and it is more reliable. Okay, so it is not really depending much on the network's bandwidth, right? But now with the automotive internet and the edge networks, cloud connectivity, and the amount of data it has to handle in the car, it is huge, right? So the electrical electronics layer is not about our wire, CAN network and switches. It is about the SOCs, the sensor, the data fusion layers between different sensors, and the network bandwidth, which can handle a lot of data processing and things like that, right? So we shifted there also very much. So in that, thanks to ADAS, for that trend has really helped us to kind of develop ourselves in the robotics, SOC, and sensor data fusion. Those capabilities have been built, right? So now, though full autonomous is not there, but literally the ADAS features have helped the market to build those capabilities in this E/E area very much. Definitely digital cockpit and infotainment layers also contributing to that move. Then data-driven understanding, this is what we were speaking about, right? So we need to understand more data and then we can contribute more. Okay, so if we don't get right data about right context and who is using why, when, and all those things, then we cannot give a right pointed personalized solution to anybody. Then if we are not able to give that solution, they will not be able to buy or subscribe to your feature which you built through your hard efforts in terms of electronics investment, software investment, connectivity, testing, safety standards, everything you did, but then nobody is there to buy, right? So that's a kind of competition we are going to face, like the mobile markets, right? And then what is about connected? Okay, so connectedness is not only for the convenience part, but connectedness, very importantly, it gives safe feeling for us, right? I am going in a car which is controlled by software. What happens if suddenly there is an update running and then that update is either accelerating my driving pedal, or though we are using steer by wire now, right? So or there is a audio shock, right? So that we are hearing, right? So it's a sudden audio shock we are hearing. Then whom I will complain here, right? I have to be connected always for some remote support, for somewhere somebody has to do the monitoring of the data, so that you can be reached out and you can also kind of connect through a proper channel, and you feel that is done, right? Yes, charging in EV, definitely it's an important one. Charging, if you are getting out of charge, or if your battery is kind of behaving very differently on that day, till then it was working for that 300-kilometer range. Suddenly on that day, after charging in 30 kilometers itself, it is showing only 20% battery is there, right? So should you believe, or should you continue, right? So these are the scenarios where connected features make sense, right? And then personalized is now, as this is the end of the day, business for humans now used to personalization. I don't want to see the same things what my friend is saying or my family person is saying in anything, right? A movie, political news, educational video, or anything for that matter. So we all want personalized to ourselves. So that feature, if we need to give, we need the customer profiles, their usage, many other things to do that. Then only we can also sell the right features to right people, so that makes sense to them, and that really converts into a whole business. So these features were not available before. So that was software in vehicle. This is how software is going to define your vehicle functions and vehicle business as a whole, right? So this is something largely driven by the way you engineer the product, the way you innovate for new features, and the way you kind of reach your customer and know more about your customer directly, rather than a one-time sale of a vehicle or infotainment or anything for that matter, right? I think after some time, if I move this is not moving. Okay, so we have seen what is the software defined vehicle attributes, right? So if those attributes are there, then you can call that as a software defined vehicle, right? So now we need to come again further down, that is at a user level and feature level that you can explain as an engineer. Okay, so what really enables it? Where are you going to be working in the software defined vehicle area, right? Are you going to be working on the middleware for decoupling the hardware and the software, or are you going to work on your E/E architecture where there are hundreds of UCs today moved into some kind of domain controllers where the ECUs are supported with more power, more control, and more centralized decision making. Now we are fundamentally moving into zonal controllers where we want to have the four zone kind of concept, and further we will move into one central computer where already Tesla kind of companies were successful. One successful company we are trying to follow and then implement it as an industry for a few years now. So that catch up is still happening. It will happen due to some reasons that we are yet to see now in the slides, right? So now I think these are all self-explanatory, right? So the service-oriented architecture is again from the software industry, where we have lot of APIs, lot of different applications. How to handle those applications, APIs, functions, prioritization, deployment, all those things will be very complex. So we have to manage some kind of loosely coupled architecture and very modular teams to focus on different smaller functions and shipment of it, and also aligning to the architecture which the software architect of the team puts in, right? So this is what software oriented architecture was doing in the software industry. Now that is also coming into automotive industry, because the number of applications that we see at the end user level is increasing, and it's not going to be manageable if you just have the kind of independent applications. We need this SOA to be helpful there. And over there updates, yes, again we seen this, but it now it's more on the technical side, right? So how cloud edge connectivity, and then how we are going to ship it through different pipelines on production, right? So this is something how we are going to automate and orchestrate this different pipelines for different applications to which kind of systems at what time, right? With what consent we can really push the update, right? If the update fails, what has to be done? Can we revert it back? So there are a lot of things to be taken care on the technology side, right? So that's more important. And the cloud-driven development and integrated toolchain. So as I was saying in the start, so AWS, Microsoft are coming in this big way. Due to there is a reason, right? Because now anything you handle, you collect a lot of data. Where you will store all the data, right? You have to go to cloud. When you want to make sense of the data, you have to go to cloud, right? So anyway, all your data engineering and the AI machine learning, it will happen in cloud for any decision making for any feature of the application here. So in that case, now it's much easier for them to really integrate with the, okay, so why you just you are just having your IDEs and then development environments local, and then trying to have trying to have two different places of storage, right? You cannot handle so much data in local. You have to keep it in cloud. Then here, a lot of independent tools are available, right? So, for example, Vector, MathWorks, and Eclipse, right? So, Electrobits tool suite, right? There are a lot of tool suites, ANSYS, CATIA, Dassault Systems tool suite. So all those things, right? They were all desktop oriented. Now they have shifted themselves to platform-based services in cloud. Basically, the same tool now will run in cloud, right? But it is still not completely ready for a kind of application as a service kind of cloud native virtual IDE, cloud native integrated development workbench. It's a maturity. That's how in software industry all the databases, Oracle, SQL, SQL Server, Netezza, everything was running individually in our system, how it became a native service in cloud. That's a maturity curve. I think in engineering also we are yet to go. The first step AWS has taken it as virtual development workbench, where they are trying to bring in the use the same data, but bring in the different tools you need. For example, if you want model-based development, you use MathWorks, right? If you want to use some simulation, you use one simulation tool out there. If you don't use MATLAB Simulink, right? And if you want to use some kind of AutoSAR based features for some function development, middleware based features, then EB Corbos or EB Resource kind of tools you can use there. So it's all possible now because AWS is trying to bring in a virtual workbench where you can, what you have done with MathWorks, the file, the data, the repository, you can again access with the other tool in the same place without replicating it into multiple PCs and everybody can work in a distributed way. This is the first stage, right? So slowly it will go to the stage where we have today how the databases have went in. So similarly, we will also see engineering things going, right? So that's cloud-driven development, and that's where the integrated tool chain we are talking about. There are a lot of work, lot of opportunities for India, especially to take up in this integrated tool chain part, where this is something really wide open area. Not many players are there yet. So it's a good opportunity for India to take it up, having a lot of software application developers and engineers from automotive industry, electronics industry. This is good opportunity for us to also play here. Then virtual validation and environmental parity. So the physical and the virtual environment, how it can be different. All my embedded workloads, all my testing which I can do in my hardware hill environment, right? So the hardware-based workbenches that we create, can we have that same specification, same kind of performance, same kind of environment? Can we replicate virtually? Is that possible? So yes, it is possible. So that's where now the overall the embedded hardware based workloads are ARM based, right? So slowly now cloud providers are also giving ARM based instruction set processors like ARM, Graviton. AWS Graviton is definitely one among the first step, and more and more to come. And we can get lot of that environmental parity. That is where a consortium called SOFI, okay, so which is primarily driven by ARM, Bosch, and AWS kind of bigger companies to see how the virtual validation can happen with a clear environmental parity and mixed kind of differentiation also need to be taken care of there. So this is something which is important. Let's go into the interesting part. We told Tesla. Okay, so Tesla has already done this software-defined vehicle way back, but now still we are talking it like a today's trend, right? So when this is a reality out there in with Tesla, why that becomes a reality so easier for them? Why still trying to kind of do that here, but still it will take time because they started as a native software company with the software shipment mindset. They seen car as a software based product naturally, right? So when they see in that way, the way the organization structure, the priorities, the kind of culture, the kind of people they have, and then engineers are there, definitely mechanical engineers are there, electronics engineers are there, but how they have structured it with that software first priority and data driven engineering was there in the culture from day one, right? That was the biggest driver for Tesla to be successful. And the second thing is, yes, they are a startup. They don't need to justify, they don't have anything to take care of the existing business, right? They can put everything into the latest. and they can build their own OS, their own infotainment. They just don't want to slow down, or I don't know what was there in Elon Musk's mind. But I see we are now able to see that maybe betting on everything at every level. They see optimization can be done through software-driven or data-driven software features. They have taken up, say, Tesla's own infotainment. It is adapted from AMD's operating system, and subscription-based features they started delivering long back. Till we are trying to see which subscription feature which customer will buy, right? So, and then their primary mode of services and maintenance is remote. They kept it from the start, right? And then they had custom AI chips, which they developed internally first, and then made the models. It is more customized to their workloads and things like that. And now, anyway, they are for the full self-driving. They are going for Samsung and TSMC for more powerful chips. But already they understood how to do things and everything. So without much friction and collaboration, they are able to do internally, and it took long time. Okay, so from 2003-4, and now where are we? It took 20 years, right? So even though they had all the control, all the budget, all the money within one company, think about the fragmented ecosystem that we have. Who will own what, right? So this is how they achieved connected, agile, flexible, data-driven, and software-first shipments. Exactly, right? So now this is the challenge, right? Tesla is putting in, and that's why software-defined vehicle cannot be a myth. You can just see there is a real implementation done, right? It is not something that it has to in our imagination. It can be like that. It can also be for that. There is a real implementation done in a different way, in a unique way. The challenge for us is how can we really adopt that with our existing ecosystem, our way of segregation of OEM, tier 1, tier 2, software services supplier, engineering services supplier, how they are all going to come together, who will own the IP, who will own the data, right? So this is the biggest challenge that companies are trying to figure out here. It's not a technology problem at all, right? It is a collaboration and business model challenge that we are taking, apart from the culture and organizational readiness, right? So this is the challenge with respect to SDV. From India perspective, we are well set on AI, data, software, engineering, everywhere, but we just have to also figure out how to do this organizational, this business model, and every other than collaboration, how we can do and then work with each other. So this is something very important for us. So again, just to reinstate, autonomous, connected, and electric are the innovations for automotive industry, right? The software-defined vehicle is an innovation for delivering these three socially contributing innovation. Autonomous vehicles will reduce accidents once it is successful. Now it is killing so many people, but it is supposed to reduce accidents, right? So when we are able to fully run the autonomous vehicles, and then it also helps the driver, right? So when they are not well or if they are not focused and things like that, so it still reduce at ADAS level. Still, it is useful. And connected, that also gives a lot of personalized comfort, convenience, safety, and performance, right? So this is all we can achieve with connected. Electric, as we all know, we are having a lot of options in our hand. Okay, which fuel type, which is a BEV, HEV, or fuel cell electric vehicle, or whatever it is, right? So we have a lot of options, a lot of innovation possible there. And these three are socially contributing innovations. But these three can be really powered by software-defined product engineering in this vehicle industry through the software SDV trend, right? So that's how we see the clear demarcated difference between the three trends which drives value to the customer, value to the society, Whereas software defined vehicle innovation provides value to the business which is running the vehicle industry, and also it helps us to get ready to the future of this business, because as humans, as today the car buyers between the age of 25 to 40, they are the most, right? So who has the money to buy a car, whether through EMI or whether through whole cash, or it doesn't matter. Okay, so this age group is now experiencing digital in every which way, right? From office, from home, in mobile, everything. So they are not going to accept a car which is not giving updated features for them every 2 years at least. So every 2 years, can we change a car? It's not possible, right? Because after you buy a home or a house which is at the highest budget, the next individual budget is going to a car only. You don't buy anything else so costly than a car, right? So which is also a depreciating asset in other ways. Still, we are buying, right? So that's a kind of thing that we are having towards it. So we definitely want quality and happiness with that. So not only we, everybody features, they want that software defined features to be available. So this is just for us, the engineering community here. Okay, what kind of use cases that we see from SDV perspective, and what are the different roles that are upcoming and already here. But with these roles internally in their responsibilities, they will go more towards software defined. Though they are a software developer, though they are in DevOps, they have to become more and more software defined, right? So that's on the use cases part. And definitely we want to differentiate between autonomous, connected, and electric roles. If you see, those are all specific to that innovation streams. Whereas if you see SDV roles, that is something related to data development, OTA, and things like that. Very specific, right? So that's a difference we want to highlight. So that's all for today. And this is what the summary of what we discussed, right? We are in a multi-dimensional challenge, not one-dimensional challenge for SDV, right? Business model change at the same time, new engineering processes, new technology, new tool stack, right? Skill change, organizational structure change, right? So priorities. Previously, a mech or electric person will be sitting and leading the engineering team. Today, a software person is coming and leading the team. So it's totally different priorities, right? So then OEM shift towards recurring revenue from the end user rather than the one-time revenue. Who will own the data? Who will own the software IP? So this is the summary of the whole SDV. So I think with this understanding, if you approach software-defined vehicle, we can go closer to the solutions much faster than seeing that as just a cloud or just a software or only AI, because in the end, it has to be useful for the user, safe, secure, and it has to be a good business model for the company also to deliver that in a sustainable way, right? And yes, that's where all our careers exist. So let's also keep an eye on what career, what competencies, what team structures, how the career path is going to change in every organization or overall, right? That's a summary of it. Any questions from anyone? If there are no questions, then thank you so much. Thanks for the opportunity.
automotive software engineers. We're very happy to have you, sir. Mr. Anindam, thank you so much for joining us, and kindly excuse my
Can you hear me? Okay, okay. Let me just present my screen.
Sir, can you speak now?
Yeah. Can you hear me now? Yeah, and my screen is visible. Is it visible? Can you please confirm if it is visible? The screen is visible.
Your screen and your voice is visible and clear to us.
Thank you. Thank you. Okay. Very good afternoon to all of you, and I'm extremely delighted to be invited by ANCIT to.
Sir, 1 minute.
Sorry.
Sir, Anindam, sir, give me 1 moment.
Okay.
Sound automating there.
Sir, Arindam, sir, just 1 minute, sir. We are fixing some audio issues here.
Okay. No issues.
Where is that laptop notes? Yeah. Yeah, I think you can speak. Sir, can you speak, please?
It's okay. Yeah, it's okay. Hello, can you hear me?
Arindam, sir, can you speak, please?
I am speaking right now.
Can you please speak?
Yes, I am speaking right now. Can you hear me? I think online people can hear me.
Coming here, no?
Yes, I'm able to hear you.
Yeah.
It's not coming in this.
There's some issue with the auditorium. Just let me know if you have been able to fix it for the auditorium there.
Sir, please go ahead.
Yeah, okay. You can hear me now?
Yeah, please.
Okay, great. Thank you very much. So very good afternoon to all of you who are present physically at Pune and also watching this live virtually on the ANCIT Tech Day. And it's an honor and a pleasure to be part of this event. Though virtually, I would have loved to be there physically at Pune, but I'm happy at least I'm able to join you virtually. The topic that I've been asked to speak about is for skilling requirements for a career in automotive software. And this is a domain which is evolving pretty fast. And, as ASTC, which is a not-for-profit society, looking at skilling initiatives for the entire automotive domain in India nationally, under the guidance and approval and affiliation of the National Council of Vocational Education and Training. We are a body which has been promoted jointly by SIAM, the Automobile Manufacturers Association, ACMA, the Component Manufacturers Association, and FADA, which is the Dealers Association. We are also supported ably by our relevant ministries, the Ministry of Skill Development and Entrepreneurship, Ministry of Heavy Industry, and Ministry of Road Transport and Highways. I was just listening to Janki, my immediate previous speaker, where he was introducing and discussing all the possibilities and the challenges of a software-defined vehicle. And as the world is moving very fast towards a software-defined vehicle, what we also call as computer on wheels, uh, there cannot be an option but to integrate the software along with the hardware that the vehicle provides. So, the automotive industry had started as a hardware industry, essentially focusing only on the equipment, which is largely mechanical, somewhat electrical. But over a period of time, software has been integrated very heavily into the vehicle. So if I'm looking at the new requirements in the automotive industry, we are looking at customers who need a user experience. The new customers are all customers with mobile devices, and a mobile vehicle is also uh, expected to perform at the same level, just like your own mobile devices. It only gets bigger and hopefully better. The cars also need to provide different levels of autonomous driving, and all of us are talking about it for quite a while, but it's quite a reality. Even in India today, we have level 2 autonomy coming in most of the new models that are being launched, and the customer preference. Customer is actually going around and searching for vehicles which has a certain level of autonomous driver assistance systems, ADAS as we commonly call, at least to get started with. Then there is, of course, the other part of the ACES framework is the electric vehicles, which is being caused by the environmental regulations and the climate changes. Shared mobility is here and here to stay, and integration of electric vehicles with shared mobility is what we are seeing in large metropolitan cities in India and the world over. And this is going to happen even faster as we go forward. Also have connected vehicles which allow for continuous communication with the infrastructure and also for after-sales opportunities for the automotive OEMs. And we are very seriously looking at the V2X technology itself. Now, what are the various major functional domains within the automotive? And I'm sure other speakers would cover many parts of this. There is a powertrain, there is engine control, there is transmission, there is gear control, so which is what makes it move. And then you have a body which has ABS, anti-lock braking system, electronic stability program, automatic stability controls, adaptive cruise controls. Then you have the interior within it, where you have, and the comfort basically within the interior and the exterior around air conditioning, climate control, wipers, lights, door seats, etc. You also have the telematics or the wireless or the communication devices, the multimedia, the infotainment, the navigation systems, rear seat entertainment. All of these are real and actual in today's context. And finally, I think most importantly, there is an element of safety that is very important in terms of seat belts, but beyond seat belts now, airbags, sensors, LiDAR cameras, all of that working towards providing a very safe environment when you are wanting to move in a high speed a situation along a highway. So this is just a geographical representation of the various vehicle functions, and all of these today require automotive software applications. And I'm sure many of my other co-speakers in this Tech Day will talk more in details about some of these areas. So most of you know this, but again, just from a perspective of setting the context before I come to the specific skilling requirements, the software-defined vehicle separates the hardware from software. It is updatable and upgradable. It is autonomous, learning, always connected, interacts with its environment, and supports service-based business models. So all of these are very important words, if you may, in this platform, which is a software-defined vehicle, which separates the hardware from the software. So software is not proprietary to a particular hardware that you are using in the vehicle. This hardware and the software, uh, separation is something which is a very important element of it. Uh, and it is a continuously learning machine that we are talking about, and it has the ability to interact with the environment and provide supports or service-based business models. So this decoupling process that I was talking about in terms of the hardware and the software is pretty important. And it's a very, very simplistic diagram of the whole ecosystem where we are talking about standardization of the hardware, um, using open source platform, developing multiple applications on that platform or the operating system to provide the necessary experience to the customer. So decoupling of hardware from the software and the introduction of these software abstraction layers and platforms are the fundamental concepts which we have already seen in telecom, in personal computers, smartphones, and the same is to be applied to the automotive industry, is already getting applied in the automotive industry. I don't want to delve too much into this. Essentially, the software in the vehicle is very intricately engaged with the E&E architecture of the vehicle, the electrical electronics architecture of the vehicle. So while we started off with a distributed architecture, moving into more subsystem driven or domain oriented architecture, to now progressively moving towards a central with a zonal architecture in the whole vehicle itself. The more interesting part about the evolution of the software architecture in the software, driven vehicle. So decoupling, as I spoke about in terms of hardware and software, is a very key concept. And one of the earliest and the most commonly known platforms that we use is the AUTOSAR Classic platform, which uses the software architecture of the ECUs, which standardize the software architecture of the ECUs and also improves the complexity management, which is to integrate the E&E architecture by increasing the reuse and exchangeability of the software modules between the OEMs and the suppliers. So a significant amount of open source on a standardized platform or an operating system, as you may call it, is what, though in automotive, we will talk about some real-time operating systems that different vehicle manufacturers have kind of designed as proprietary. So applications of these AUTOSAR Classic would be written in C programming language, and then we have started moving as systems get more complex and needs over-the-air updates. The AUTOSAR Classic has gradually moved into what we call as AUTOSAR Adaptive. And this is in generally C++ programming language. And these versions of AUTOSAR, Classic, and Adaptive are the key software standards for the automotive software and are very basic if you are wanting to build a career in automotive software. So what are the key skill domains? And that's what I wanted to focus for my presentation today. We'll talk about a lot of very fancy jargons, but let me tell you the basics of coding is something which you must be able to have, and efficient coding, so to say, I would say, because the process times and the reaction times, which we'll see later, are going to be in sometimes, most of the times, milliseconds, some cases nanoseconds, because we are talking about a moving vehicle here. So familiarity with all the standard language platforms, understanding of scripting languages to automate the tasks, manage the build processes, and interact with the the entire DevOps environment is very critical. And this is something which you cannot escape. It's very foundational, and you must be able to master the code. Then we talk about the operating system expertise, so there are different dominant players. We've already talked about AUTOSAR. So these are the real-time operating systems which are ensuring real-time response and resource management in all the critical systems of the vehicle. Linux itself is also gaining a lot of traction, especially in areas around infotainment systems and connected car features, because it offers a significant amount of flexibility of the operating system. The third piece, which is very critical, is about the networking know-how, because you interact with the hardware, the entire architecture of E&E. You have to have an understanding of the CAN bus and enabling the communication protocol for in-vehicle system, which enables the data exchange between the electronic control units or ECUs in different parts of the vehicle. And of course, familiarity with Ethernet and other similar protocols like FlexRay, etc., are will be very, very valuable. So you need to pick up. So as you can see, when we talk about an automotive software engineer, we're talking about somebody who is very distant from hardware, will probably not work. You need to have a certain amount of understanding of the hardware. And this is where we come to the next skill, which is around the embedded system architecture that you need to understand, because you must understand the hardware limitations and the real-time constraints of the various microcontrollers and the ECUs. So embedded C programming, optimizing the codes in the very resource-constrained environments, real-time impacts are very, very important in terms of an efficient performance and the reliability of the system. Having spoken about these very key specific technical areas, the other key skills that one must look at is in terms of having a very relevant understanding of what's happening in the industry today. How is the customer preference changing? In each of the key vehicle system areas, in powertrain area, in braking area, and steering area, and how can software, how does the software interact with them, and what could be the possibilities of the new frontiers? And that's what builds a career in this domain, essentially. Also being aware of the ever-evolving area of industry standards and regulations around AUTOSAR, around the various ISO standards, safety standards, interoperability standards. Various countries have country-specific standards, So if you are designing a vehicle for the European market, which is a common market, let's say, there are certain standards which are absolutely common across each European market. But then there could still be very, very country-specific requirements that are there. And as a software engineer or a developer, you cannot say no, that I don't understand this, because this is a domain of somebody who has a special role to understand those standards. You also need to understand the standards and what those implications in your software, in your area. How can you ensure the right kind of testing of use cases, etc., according to every relevant applicable standards and regulations. And this is very important. And finally, I think very important, while we may say that this is like a soft skill, but as an automotive as a person who wants to build a career in automotive software, analytical and critical thinking skills. Cliche terms can't say that, oh, yeah, you can forget about this. Your ability to diagnose issues, break down the problems to finite solvable units, and find solutions in certain constrained environments are very, very critical for you to uh, you know, have that skill, develop that skill, and this can be developed actually. So a lot of people say that uh, people are born with analytical critical skills. I say no, yeah, that's not true. You must pick on projects which engages you on these processes while you are learning, while you are in your uh, education, or even at the early part of your career when you have started working. You need to pick up projects which allows you to do that. The other piece is about very strong attention to detail, micro detail, because, you know, you must understand that we are talking about a vehicle which can move at a fast speed and which can actually take away lives of people around the vehicle or people inside the vehicle. So it could be very fatal if there are small errors, and it can have tremendous consequences. Uh, Even when we started our career in the industry in mechanical parts, the mechanical parts used to have, uh, uh, you know, uh, one was from a value classification, what we call as a typically in materials management area or supply chain area as ABC classification. But then there was a safety criticality area. So there are parts which have high value, not have a safety value, but then there could be even a small bolt or a circlip or something like a bush which can have a safety implication. And therefore, from a safety criticality perspective, that's like the most important part. So if we are looking around for software applications in vehicle in certain areas where safety is involved, you have to have, you need to be very, very meticulous, very, very strong attention to detail in what you are working on. Having spoken about these key skill requirements, I would also like you to focus on, I must focus on three key automotive requirements from a software perspective, which you must not forget. And it may not be very relevant for a software application in another domain, but as far as the automotive domain is concerned, this is very, very critical. Number one is timeliness requirement, number two is dependability requirement, and number three is safety requirement. And what do I mean by each of these three? Let me just quickly explain. If I talk about a timeliness requirement, the best example I could pick was for the airbag system to inflate in case of a crash. It is a real-time system with very strict timing constraints. For example, during a crash, you want the airbag to inflate just at the right time, not too early, not too late. The airbag controller must guarantee that strict timing constraints are met, So uh, real time is not same as being fast. Real time means specific timing requirements must be fulfilled. The moment the event happens, if it opens before the event happens, or much before the event happens, it doesn't work. The event has to happen, then the inflation has to happen. It cannot happen too late also, because the damage to the person will already be done if the airbag doesn't open on time. So this is a very, very perfect example of timeliness. So the software controlling the deployment of airbags has about 15 to 40 milliseconds to determine which and in what order to activate. So the specification is in terms of lower and upper bounds in terms of the response time. The metrics must include worst case response time and the tardiness of the whole process execution, essentially. So this element of timeliness within the software that you design and test is very important, and this will be required in many cases, even in electronic brake stability, etc. areas as well. Dependability, we talk about specification in 3 dimensions, which is availability, which means readiness for the correct service, which talks about the mean time to failure and mean time to repair kind of a metric. So which is basically the probability of the system being ready for use, you know. Second is the feature has to be available. The feature has to be reliable, which means the continuity of the correct service. It cannot be that it is not available and it's not always available. Always available becomes like a reliability that, and it doesn't become available when you don't need it to become available. Okay. And then finally, the safety specification of dependability, which means that you should not reach catastrophic states because of a software malfunction. Just 2 examples. These are slightly old examples, but very classic examples. 2005, about 160,000 Prius hybrids had to be called back because the car would stall and shut down. And because at that point in time, that entire update had to be done locally, physically by flushing it. And the time required per car was about 90 minutes. So you are basically using about 240,000 man hours to fix one bug, which had gone into production. So you can imagine the quantum of impact that it would have caused. In 2008, Volkswagen recalled about 6,500 cars because of software causing a very unexpected increase in the RPM of the car when the air condition gets turned on. And you can see that the two systems are different, but it it got connected because of a software bug. And that dependability cannot be overseen or overlooked, that I'll fix in another version of the car, because those cars which have gone out will also have to be fixed because it can cause safety issues as well. And safety itself is so much very important because the control system must remain safe. Uh, there are no hazardous state. You cannot have fire. You cannot have high temperature. You cannot have erroneous conditions. And you must get certified by an independent agency. So which means that your software needs to be tested for various use cases all the time. Security, which means that the system is open to external observation and control, which means today's connected cars actually have a greater security, but then it also opens up on the cloud side the whole area of cybersecurity issues. So confidentiality, integrity are very important, which has to have secure protocols. You're driving a car and your car gets hacked, obviously it's not a desirable situation. Validation of your privileges, who can do what. There are validation in the cars today that the screen cannot play certain things to, if it is in the vision of a driver. Only if it is on a rear seat entertainment can it have those displays. Those displays can actually have videos and multimedia engagements, etc. But these are very, very critical skills to pick up when you are looking at developing your career in the domain, in the area of automotive software systems itself. I'll stop here and I'll be happy if there are any questions. I'll be happy to take those and respond to them as we go forward. Any questions, you can type in the chat box or you can ask me verbally. I'll be very happy. Ramesh asks, can you suggest good learning modules or certifications available? Uh,
Question, sir.
Yeah, can you just hold on? I'm just responding to Mr. Akhilesh's question, then I'll come to you. Okay. In terms of good learning modules or certifications, there are a fair amount of programs available online by different training providers. ASDC and ANCIT also offers a government recognized certification for the program on AUTOSAR, and we also now have introduced a program on ADAS. So these programs are also available through various partners, including ANCIT, and we will be happy for you to connect with ASDC or the ANCIT team to take this interest further. Okay. Yeah, please go ahead. Somebody was asking a question orally.
1 second, sir. So, hello,
Yeah.
sir. I had a
Yeah.
related question only. So, I wanted to understand the institutions that are associated for these trainings or these upskilling activities.
Right.
I mean, are there any classroom classes, or these are online sessions, or if there is any hands-on that happens? So, wanted to understand that actually.
Sure, sure. So, if you talk about, there are some online classes as well, but there are institutions, and as I said, ANCIT itself is one of our esteemed partners who offers hands-on classes to work with various embedded systems as well. In terms of converting your learning into practical projects, which allow you to ensure that you've learned the right amounts.
Thank you, sir. Thank you so much.
Thank you. Thank you. Any other questions? We'll be happy to take, or otherwise we will close this session. Okay, if there aren't any questions, if there are any questions, you can always send it later to me through my email, you can go to the ASDC website, asdc.org.in, and connect to us on questions around this for any specific information. And we'll be happy to support you in your journey for a career in automotive software. Happy learning for the rest of the day. Look forward to learning a lot myself as well. Thank you. Over to you, ANCIT team.
Thank you, Arnab sir. Thank you so much for joining. It was a pleasure working with you. So, team, let's go back for lunch and let's join. We will reconvene at 2 o'clock, 2 p.m. Indian time. So we will have some very exciting speakers, very powerful speakers in the afternoon. We have Christian, the chairperson of AutoSAR Forum, joining us, and he'll be talking to us on what AutoSAR is going to provide as the middleware for the SDV. And then we have, I'm sorry, that will be Michael, the chairperson, and then we have Christian Hustle from Star Electronics. We'll be talking about the virtual ECUs versus real ECUs, a lot on the Ethernet stack, and he specializes there. So I think that will be very interesting. And my personal favorite, looking forward to hear from Umesh Kiramat from Electrobit, and I'm really curious to find out what EV has to offer in terms of SDV operating system. I've heard of real-time operating system. So pretty curious to learn from him as well. And finally, we have a young speaker in Kunal Gupta. A very passionate engineer, doing some great job. So he is going to be sharing his experience. He's also the founder of GetABig. So he'll be sharing his experience on functional cluster. So how the E architecture has evolved from a traditional architecture to a domain architecture to a function cluster, and then finally evolved to an SDV. So he's going to share his experience on that. So some very interesting and very powerful speakers in the afternoon. Please stay tuned. Let's join back and reconvene at 2 p.m. Thank you.
Karthik, one question. What time are we joining back?
2 p.m. sir. 2 p.m. We'll reconvene at 2 p.m.
What about people who are remote lunch? You can order through Zomato?
We can order, sir, but bill you will have to pay on your own. That is the only thing.
Okay, sir. Thank you.
And we have our senior gentleman Narayan Swami, sir. You can send it to him. He'll reimburse the bill.
Okay, sir. Okay. We'll join at 2.
Yeah.
Okay, sir. Thank you. Bye-bye. ಅದೇ ನಿಂತ್ಕೊಂಡಿರ್ಬೇಕು ಅಂತ ಸರಿವಾ
Hello, Mikhail Nicholas. Good morning.
Good morning. Can you hear me?
Yeah, I can hear you.
Is this
So we will start,
yeah,
in another 8 minutes, Michael.
yeah.
Thank you.
Good afternoon, everyone. We'll start the afternoon session in a minute. Nicholas, is our voice audible to you?
Yes, for me it is audible. Can you hear and see me?
Yeah, good afternoon, everyone. Thank you so much for joining us in the afternoon session. So today the first speaker in the afternoon session is a very interesting person. He's going to talk about two very most used buzzwords in automotive industry today, AutoSAR and SDV. And he's going to kind of bring to us on how AutoSAR is trying to bridge this gap of fulfilling the platform needs of SDV. And we're pretty excited to have you, Michael Nicholas, the chairperson of the AutoSAR consortium. Thank you so much for joining us. It is a really a honor and pleasure to host you. A quick introduction on Michael Nicholas Horrett. He's an active member of the AutoSAR steering committee representing Conti, and he's also the current chairperson of the AutoSAR forum. He has been active. He's really been active in the AutoSAR standardization since 2013 in various roles, including being the AutoSAR steering committee representative for Conti for 4 years. He is interested in preparing the AutoSAR standard to meet the challenges of automotive industry and guiding the whole organization through the journey of SDV. So we really look forward to hear from you, Nicholas, and and we also look forward to see what we have in store as a young engineer in SDV in AutoSAR as well. Yeah, thank you. Over to you.
Thank you very much for the nice introduction. So I've brought to you today, and I still need to share my screen. I recognize, I would assume, yeah. I've brought to you today several topics. Let me know if my screen is visible.
Yes, Nicholas, it's visible.
Yeah, okay. I wanted to talk to you today about several aspects on AutoSAR and how it relates to SDV. So we're going to talk a little bit about history, where we're coming from with AutoSAR. You can see your anniversary logo, so we just are out of our 20th anniversary year. Then I also would like to talk to you a little bit more about what is the base that we think software-defined vehicle will be running on. So zone architecture, and of course, we will go to the main topic of the talk, where we then have a look on how AutoSAR sees the SDV in general, how it sees itself being placed in the landscape of SDV, and how it wants to reach the goals of SDV in the future. So very excited to be here, and thanks for the invitation. And hopefully we have also very interesting questions and discussions after the presentation. So first of all, I think all of you know AutoSAR, or most of you know AutoSAR. So what's the mission of AutoSAR? So it's a global partnership of leading companies in the automotive and software industry with the goal to establish a standardized software framework. Not only the software framework, also the EE system architecture. And it is not only for previous generations of cars, but also for the intelligent mobility of the future. And I would like to quote here the AutoSAR spokesperson, Günter Reichert, was also one of the founding initiatives. He always says, if a company develops alone, it's a proprietary solution. If it is shared and used by several partners, it becomes technology. And with broad standardization, it becomes state-of-the-art and elevates certification.
Michael, sorry to disturb you.
Yeah.
Your voice is a little feeble. Yeah, it's not audible, Michael. I think it's for all of us here.
They're not audible.
Turn off the.
Okay.
Michael, can you please speak?
Yes, I can speak.
Yeah, I think it's. Just give me one moment.
Yeah.
Sorry.
Can you please speak, Michael?
Yes, of course, I can speak. Test 1, 2. It's better now? Yeah, can you hear me better now?
Oh, it's perfect. It's perfect, Mike. Yeah, please go.
Okay, good. Thank you very much. Sorry about that. Technical difficulties on a virtual session. So for the auto submission, I just explained that we are a standardized software framework with also the goal of OpenEE system architecture for future mobility. And as mentioned, Jutta Reid, our spokesperson, says if a company develops a standard, develops something alone, it's a proprietary solution. If it is shared, it gets technology, and if it's standardized, it becomes state of the art and elevates certifications. And this is exactly what we would like to achieve with AutoSort, that something standardized that is beyond state of the art and is also reference for all the different solutions in the automotive industry when it comes to software frameworks in the e-system architecture. So the development collaboration of AutoSort is growing since our founding day 2003. So we had 2023, 365 partners. If you look at, we're currently updating this wheel, so to say, but if you look at the top selling OEMs from 2019, 21 up to 22, are basing the E architecture on AutoSort. There is one famous exception here. So this is mainly because they have their own way of developing the E architecture. But nevertheless, when they're asked from an ECU, from a tier supplier, there's also a very good chance that the basic software inside of ECU being asked for is also based on AutoSort because of the platform strategies of the suppliers these days. Then I would like to talk about the basic principle. I think this is relatively known, but just to remind, so the basic principle of AutoSort is to enable the exchangeability, of supplier solutions, exchangeability also of the manufacturer's applications, and also exchangeability between vehicle platforms for reusing your software, and also different models, different brands, or also on different suppliers. That basic principle holds true for 20 years now. It also holds true for the AutoSort platform, and also holds true for other things which we might start in the future. So looking at 20 years of AutoSort, so 23 has been officially founded. Before there was activities under the codename OSOR without the out. In 2005 there was a first release, as you can see here, the very old pictures from the basic software. Was not very complete, but in 2006 there was a first complete release with the basic software. 2009 and including the RT, 2009 there were several very important things being added to the standard, like multi-core support, like a lot of concepts around functional safety, but also Ethernet. Following years, there were derived applications were allowed. New development methods were introduced in 2012. In 2013, we finally celebrated 10 years of AutoSort. This year, we also released 4.1.1, which had timing analysis, also extended diagnostics inside, and also acceptance tests. The following years, we had also other concepts like global time sync introduced, and receiver serialization, CAN flexible data rates, and finally in 2017, after 2.5 years in development, we released our first AutoSort adaptive platform, which contained back then 14 functional clusters, and also an initial demonstrator where those functional clusters have been partly implemented. From 2018 on, since then, we are doing synchronized releases, so we're always releasing AutoSort Classic, AutoSort Adaptive, and the foundation at the same point in time. And then we also started to unify the release naming. And 2022, so end of 2022, we started the opening strategy, and we also started to build a more global presence, with hubs in China, and Japan, and the US. And last year we have been celebrating our 20th anniversary, and this year, of course, we are full steam ahead, also still continuing to execute our opening strategy. But we'll have also some slides because the opening strategy is also to contribute to the position of AUTOSAR in the software-defined vehicle. Having said that, how is it possible? How can a standard like AUTOSAR, which is started back in the days when there was no multi-core, only limited network connection, still be up and running 20 years later? We asked ourselves two questions and came back that we have basically four main lessons learned, which I would like to walk you through, which in our opinion helped us in these times. Yeah. First of all, let's have a look on the contribution of the core partners. So this is basically how AUTOSAR started in 2003 with this kind of distribution around the world. And this is basically where we are now. So these are the pins where we have partner companies. Also, here there are a lot of pins in India, and 365. And this is also our first lesson. Yeah. So one of the important things of such a standard to be successful over so much time is the global footprint, which we also had from the beginning, because we need to know what happens in the ecosystem, what happens around the globe, but it also builds an ecosystem around the standard. It's global, not local, but a global ecosystem. And it also helps with the acceptance of a standard. The more markets participate in the same standards, the more it is also accepted and the more also the ecosystem is built around it. That's the first lesson we have. Also, here you can see a very, very rough, zoomed out approach of the AUTOSAR methodology. So in AUTOSAR, you have basically basic software. You have also activities around the system development. So you have also virtual function bus-based function view on the development. Finally, software components. Yeah. And at the end, you will get an EC extract. You will have a basic software, and you will have software components that are integrated into an ECU. Yeah. And this methodology, it basically also leads us to two main things. Yeah. First of all, we have standardized exchange formats. Yeah. And the standardized exchange formats replace contracts from previous years. Before AUTOSAR existed, there were always things like an eRahmen or an Excel file that specified CAN data or that specified the interface of an application in a document rather than in a machine-readable exchange format. Yeah. And that, of course, leads us to lessons 2 and 3. First of all, if I talk to somebody who has AUTOSAR background about a client-server operation, he knows what I mean. The standard language or sender-receiver interface. We have established a standard language. It's way easier to communicate with each other because we are all using the same terms. Yeah. And second, of course, something like the methodology, which is mimicked to what's the established or desired workflow in the market, helps us also to guide each other along the value chain of car development, in which portions of the value chain they have to do which activities or what activities are expected, but also in which exchange formats the results of the activities along the value chain are then communicated. Now, this is a very rough picture from our view how the EE architecture evolved in the last years. So it all started with mechanic in the 70s and some electrically support in the 1780s. Yeah, ECU started to be first connected. So first centralization started, gateways had to be introduced, infotainment was also leading to a lot of consolidation again and integration. And then there have been the linked networks. Yeah, the linked networks was basically the challenge where people had struggles to integrate a lot of boxes together into one car. And this is where AUTOSAR was founded. Okay, we need to deal somewhat with the integration of all of those boxes into the same car. And it's difficult, so we need to do something about it. That was the main trigger why the founders of AUTOSAR founded AUTOSAR. Yeah? And then there were other activities like domain fusion, and a lot of those innovations back in the days were then driven by EE architecture innovations. For example, security. Yeah? Everybody might know this famous replication attack, where they took one car, they sniffed all of the CAN messages, reproduced it in the other car, and the car exactly behaved like the one car that was driving, and which showed that we need to do something on our e-architecture to secure communication. Then, of course, vehicle computers played more and more a role in the following years. So, with also the possibility of more computational power in the car. And the new interact that we see is, of course, the software-defined vehicle based on zone architecture. But in reality, zone architecture is just a vehicle on which software-defined vehicles can run on. It also support a bit the idea of separation of hardware and software. And what have we learned from that? So here, for vehicle computers, we have built the Atos Adaptive Platform. What we will do about the software-defined vehicle, we also will see later in the talk. But this means that it is very important for such a standard to survive those years, to understand the changes early. And such a huge community like we have in Atos helps us to understand the changes early. And of course, you need to adopt. It doesn't help to simply understand the changes, but you also need to see what's the impact. How do you need to adopt to as a standard to that to stay long-time viable? This is the fourth lesson. Now we have talked a little bit about zone architecture, about software-defined vehicle. I would like to take the opportunity with you to a little bit look on what's going to be the impact on how we're separating software. So for that, I would like to introduce very quickly the zone architecture itself. So in the zone architecture in the heart, you will have something like vehicle computers, which do the heavy lifting and calculation, all of the cognitive functions, and they are usually then connected via service-oriented communication. For example, some IP or TDS, yeah. And then next to the vehicle computers, you might have the zone ECUs. Those are typically multi-core ECUs, so these boxes depict several cores, so to say, yeah. And they are then again consolidating a certain area of the vehicle. So like the zone, that's a physical zone.
Hey, Michael,
yeah.
it's Bhishma from here. Can you be a bit louder, Michael, because we are not able to hear clearly.
I will give it a try. So the zone ECUs are basically physically adopted into a certain zone of the vehicle. And in this zone, they're usually consolidating a lot of inputs coming from signal-based communication, like CAN, CAN-FD, 10 Mbit Ethernet. And connected to those are typical actuator and sensor ECUs. Yeah, so they are basically the typical ECUs that read in an input and calculate an output. Yeah, and below them we still have subnets with LIN and CAN, and the subnets usually have then non-intelligent actuators and sensors, which are not very software heavy. This can be a simple button in your dashboard to an LED blinking in your car. So it's very simple means to interact with the driver. Yeah. And if you take now the zone architecture, you have also of course the cloud interface. Depending on how the architectures look like, this might be on a vehicle computer, it might be on a zone, or it might also be on telematics Unix somewhere below the zone. And if we now take this picture and think about an analogy to the human being of the zone architecture, and I have started that already. And this first analogy is basically how does the vehicle sense things. So if you take to the human, you have eyes, you have a nose, you have the skin, ear, your tongue, and you're taking in senses. Yeah, and the analogy on the car for that would be basically camera systems, LiDAR systems, radar, ultrasonic, tire pressure sensors, pedals, buttons, HMI, also tank flap interaction, and so on. So all of those sensors are the logical input to the system core, as the 5 sensors I've drawn here are to the system human. Yeah, and this is by accident that I discovered that, because I had to prepare a talk, and then my little girl was basically having in school all of the human senses, right? And I said, that's a very nice analogy to put in place, also to relate to how a vehicle understands its environment. And that's not the only thing we have in a vehicle that can be mapped to a human being. We can also say we have a brain, we do cognitive things, so we are thinking, we are taking decisions as human beings. And if you take this on a zone architecture, the cognitive level of the system core would be the vehicle computer. Yeah, so some of the functions that are of cognitive nature might also be in zone ECUs. For example, they have a very hard timing requirements, but that is the potential analogy to the human being. Then the next is the muscles. So also the car has muscles. The car is moving, so it has a steering angle. So in which angle it goes, it has deceleration, it has acceleration, it has airbag, lamps, sounds, light. So this is basically how the car executes things. So the human being executes things by its muscles, right? And the analogy here is the execution level of the car is like the human muscles, and also including the reflexes. We will come to that later. And of course, those sensing, the cognitive thing, and the muscles, they need to be connected. Yeah. So how is this done? In the human body, you have as a backbone of communication the spine. Yeah. So every nerve highway, big nerve highways, similar like the Ethernet nodes, are going through the spine. And they're more or less abstracting all of the sensors and actuators in a similar way than the service domain does in a zone-based architecture. And of course, there is also the need to translate this information then into the sensors and actuator space, or in the sensor and in the sensing and muscle space methodology. And this is then usually done via nerves. So if you can look at it, the nerves, they are connected to your skin. They make you feel those things. They're connected to your eyes. They're connected to also your muscles to trigger contractions and so on. So they are then at the end of the day the signal of PDU-based communication in your car. Yeah. And taking that analogy, that basically means if we look at it, we have for the sensing part mainly happening in sensor ECUs and non-intelligent sensors. For the brain part, mainly happening in the vehicle computer and partially also in the zone ECUs. For muscles and reflexes, we would be in the actuator ECUs and non-intelligent actuators. And for the service-oriented communication, we would be in a spine analogy and also in the zone translation. And those nerves would be in the signal PDU-based communication by medium and low speed bus systems. Yeah. I still get the feedback in the chat that the audio is low. Let me see if I can do something about it. Let me do something. Let me know if it's better now. Okay, I tried to switch off some background noise reduction. Yeah, maybe this was the reason. So I'm following the chat, so let me know if it gets better again. Yeah. So then with that analogy, we can also think about how will our software be divided in the future. And for example, here taking a brake architecture, we have a brake pedal sensor, we have a brake decision arbitrator, and with a brake actuator. Yeah. And the brake actuator, for example, is an example of that kind of reflexes. Yeah. For example, an ABS algorithm is an algorithm that is a real-time control loop, and it's not good to remove such a real-time control loop into the cognitive space. You can also compare to the human being. If I take a cognitive decision as a human being to walk to the next supermarket, I'm not giving each and every muscle cognitive commands on how they should contract and uncontract, right? So it's like a reflexes. I take the cognitive decision, I go to the supermarket, and my body does the actual moving. Yeah. And if we take this example, it's a very simplified example, just for the sake of demonstration. Yeah. And we apply that analogy to the human being. There would be basically the brake sensor pedal being the sensors. There would be some nerve information for emergency brake coming. The brake decision arbitrator would be the cognitive function, so the brain, and the algorithms on the brake would be the muscles, which then at the end apply the brake force. So coming from here then to here. And now we can take this analogy and apply it to a zone architecture. Doing this means, of course, maybe the brake pedal sensor is here, maybe the decision arbitrator is here, and the actuator is here. We need still to connect those via nerves and via the spinal system. So what happens here right now is that our traditional way of thinking automotive functions, it's sliced up. It's sliced up into different ECUs, right? And this is one of the consequences. We're doing horizontal cuts through our functions, to our ECUs, by applying zone architecture and applying that at the end of the day also the software-defined vehicle. Yeah. Because if we do this now, we see that this will then be allocated to different kinds of ECUs. So this is basically a little bit of an analogy what will happen because of the move to zone architecture, to SDV with our functions. So we will have to slice them up in good portions and think about what's the correct interfacing level of them. Then the two platforms, AUTOSAR Classic and AUTOSAR Adaptive. These are the main platforms AUTOSAR standardizing right now. There's also an activity started which is called Automotive API, which we will come to later. What's the main difference? So AUTOSAR Adaptive is developed for the real-time requirements in the mid-range, in the millisecond range, Classic in the high range. For safety criticality, Adaptive is at least ASIL-B. So here the current restriction is not the standard itself, but the current restriction is usually coming by the hardware that the software is executed on, because you need an accordingly qualified hardware to be able to then also execute an accordingly qualified software on top of it. And of course, the other main difference is the computing power. Now, applying then AUTOSAR to a zone architecture could look like this. So you have then AUTOSAR typically running on the intelligent sensors and actuators on the zone AUTOSAR Classic, and on these vehicle computers you might have then an AUTOSAR Adaptive and AUTOSAR Classic, also a third-party platform running, usually separated by a hypervisor. And now, based on that zone architecture, a lot of people think that the zone architecture is an additional enablement for the software-defined vehicle. Let's have a look at the software-defined vehicle and how it looks like. So we have, at the bottom, we have the vehicle infrastructures. So we have the sensors, the zones, the ECUs, and the actuators. And we have the cloud infrastructure. The software-defined vehicle will not stop at the edge of the car. It will also go further into the cloud. Yeah. And in the car, we will then have compute platforms. And those compute platforms will basically do the calculation, execution of software in the car, but we'll have also execution in the cloud. Yeah. And first of all, of course, there will be then hardware platforms where the compute is done on. There will be a hardware abstraction API. There will be execution environments like, for example, AUTOSOR Classic, AUTOSOR Adaptive, but also others. And on top of them, there will be platform services, which then also will provide some kind of vehicle or automotive API, how you ever want to call it. And then, of course, in the edge, you have the simulation verification use cases, but also use cases like digital twin, predictive maintenance, and other cloud services. What is not to be underestimated in the software-defined vehicle is that it will be very important to have a very efficient DevOps-enabled workbench toolchain in the sense of that you can do very quick updates of your software that is very automatized, so that you can also quickly replay things. Yeah. And when we take this as a kind of a high-level reference of the SDV, it's not like very detailed. It's not like, and if I ask 10 people, I will get 10 different views of SDV. But let's take this as a first logical view of SDV. Let's map it to what kind of consortia are out there. Yeah, and this is basically just a principal mapping. We have here AUTOSOR taking care about mainly platform service, execution environment, hardware platform. But also in the future, we want to start something which is called open projects, and we are having some execution here. We have Eclipse SDV taking care about some things. We have Covisa, we have CNCF, we have the CAM, we have Kronos, we have Sophie. Yeah, so there are different organizations doing different things. So what will be key for the software-defined vehicle is that we need to create consistent legal framework that those things can work with each other. And also we need to collaborate. So complementing each other is very key. Yeah. Also as an industry, we should avoid double work. Yeah. And we should also avoid contradicting results and assure compatibility. To do that, we had last year already a workshop in Cologne between the organizations AUTOSOR, Eclipse SDV, Sophie, and Covisa. And we have announced at the CES 2024 that we are building an SDV alliance, yeah, where we exactly want to make sure that we will have not a distributed, small scale, fragmented solution of the SDV, but we build something from the automotive industry for the automotive industry with several consortia together. This activity has now started, and also we will hopefully be able to present more details in the future. So as I said, the SDV is something not a single company, not a single consortium will be able to do on its own because it's so huge. It has so many technologies inside. So we are very much convinced that it will take a joint industry effort. And to be able, as AUTOSOR, we are very, from a contract perspective, we are very closed in the sense of where you can apply it and so on, so how you can use it. So we are currently working on a set of measures to enable this collaboration with the other organizations and to enable a more open collaboration in general. So we have basically six measures identified, 4 of them already executed. So the regional representations is we want to better open up into the regions, as I mentioned before. We have now different hubs in China, in Japan, and in the US. We have also third-party collaboration. So actively speaking, we're actively searching for partners out there who have an interface to AUTOSOR, like for example, the ones that I mentioned before. We have Premium Partner Plus to get our premium partners the possibility to get more involved into the AUTOSOR standardization. We have also the derived applications, so you can use AUTOSOR also for other applications than automotive. And what's in the pipe, and currently in the finalization is an easier access to a limited scope of AUTOSOR work, which I will come in a second, and also the Automotive API project. And for this access to AUTOSOR work, so we want to be compatible on bus level. We will introduce a new partnership type, Associate Partner Lite, which is for free, and it gives you exploitation rights only for a very limited scope of AUTOSAR, so be compatible on the bus, so to say. Yeah. Now this enables also in the ecosystem that the tools that are doing bus monitoring based on AUTOSAR protocols and other things are more attractive for partners where their core business is not embedded software. Yeah? And also we are currently working on AUTOSAR Open Framework with a goal to contribute and collaborate more in the open with other consortia, yeah, especially in this SDV ecosystem. And with this, we will be able to also develop under new licenses, so not under the license of the AUTOSAR development agreement, but under new licenses, new things together, yeah. And with that framework, it will also be open to non-AUTOSAR partners and others to then contribute to topics that are very close to AUTOSAR and also to develop joint solutions. One of the first things we want to do is an automotive API, which is basically then consisting of things in the open and things that are close to AUTOSAR. And here is basically I'll jump in there in a second. So where do we come from? So stakeholders for such an automotive API are, for example, vehicle users, but also automotive service providers and also non-automotive service providers, like, for example, insurances or service to take credit card charges, purchases you did in the cars, and so on. And based on that, of course, you have now in a little bit nicer way this EE architecture with high performance controllers, zone controllers, and other ECUs, which I said in the past. And of course, you would have in the vehicle users case in an app which wants to call an API, for example, such an automotive API, and then you need an according endpoint in your embedded system. And the same you could also do via, for example, an according automotive service provider, and similarly also like a non-automotive service provider. And this is basically the scenarios which we're currently seeing to communicate with the car on an automotive API level. And to reach these scenarios, we have basically also in-vehicle apps, which we then also call this vehicle API. And I won't go too much into details here, yeah. But what's more important for us is the kind of building blocks. So at the end of the day, we will have kind of an HPC, yeah, which has a gateway for AUTOSAR Adaptive, for example, and the according API that is the same in the cloud and in the vehicle. This automotive API. So what we need to achieve that is several building blocks. So we will have a standardized data catalog. This is, for example, an API specification, also payload encoding, and in-vehicle data and service specification. And if we look at those four things, they already exist today, but they need to be combined. So first of all, we need some kind of methodology and tooling to combine the standardized data catalog, the API spec, payload encoding, and the in-vehicle data and service specification to then be put on such a gateway to be able to enable communication between applications in the cloud and data in the vehicle, like reading data, setting data, whatever we want to in the vehicle. Yeah. And in today's technologies, the standardized data catalog, for example, VSS, COVESA is a standardized data catalog. They are semantically describing different kind of information in the car, different kind of information that is expected from the car and should be transferred to the cloud. When we come to payload and API specification, there is a VISS from W3C. And when it comes to the in-vehicle service specification, we have XML in AUTOSAR describing, for example, our services in some IP or DDS. And we could then create a coding methodology and tooling to link those things together to create such a VISS gateway, which is then able to communicate with the rest of the vehicle, because after this gateway, everything will be either some IP or DDS messages. And with that, we will have a complete use case from the cloud via some payload encoding and semantic view into the world of some IP. And this is exactly the AUTOSAR API project, yeah, where we join forces with other organizations, where we reuse then these existing building blocks, which are also in open source, and which we then also use to improve each other's building blocks. So we're providing them feedback to VSS, to the VISS, and so on, to improve those solutions, but also getting feedback from them. And then with such a tooling and such a specification and example implementation of the gateway, we will then show how this is going to be solved in a concrete use cases. Yeah. So this is at the moment the overview of the target, yeah, of the Automotive API project, and it will also be hopefully released the first time this year. Yeah, it's coming just from a steering committee meeting where we have discussed that. But this is then still to need to be confirmed. Yeah. And as a summary, as I mentioned before, we have a 20 years of history. We have a lot of partners worldwide, so it seems to be somewhat accepted. Also, we want to gain more speed and cover also more topics, especially in the collaboration use case, by our opening strategy. AUTOSAR is a relatively huge ecosystem, and also it includes different activities and standardization interfaces and standardization efforts, to build an overall arching framework for the software-defined vehicle, where AUTOSAR is one piece contributing to the software-defined vehicle. AUTOSAR platforms are compatible to each other with a high level for safety and security and high demand for safety and security. So therefore, a sound basis for certification, and we are putting a very strong focus on quality and on early provision of key features. And this is basically where I would like to end my talk, and would like also to go into the question and answer sessions which you might have. And hopefully the sound got somewhat acceptable after my adaptation. We can go now through the details of all of the questions you had. Thank you.
Let's open the floor for questions. Members in the team, if you are in the teams, if you have any questions, you can ask. Muted. Huh?
So yes, you're audible. I've received 2 questions from the chat. Maybe I answer them as a kind of an icebreaker. Mm-hmm. Yeah. So one question was, apart from NVIDIA, Qualcomm, NXP, Mobileye, Renesas, are there any more hardware platforms available now? That is a very specific question on certain companies. I don't know how this availability, what this availability was referring to. I think there are way more hardware platforms available in general than those which you have mentioned. Maybe not all of them yet qualified for the automotive purpose, yeah. But as a standard, as an AUTOSAR standard, we are not building a solution to run on a specific hardware. So there's no, for us, it's not any intention, to have something specific for hardware and vendors or to exclude certain hardware vendors. So it's up to the hardware vendors to create devices that will then at the end be able to host such systems like AUTOSAR Classic and Adapter. Yeah. But I personally know that there are more than this hardware platforms available. Yeah. Then the second question I've received is, are the automotive API based on REST or any other specific protocol from VSS W3C? That is a very good question. So I go back here, the VS V2. I think for the transport they have, to my knowledge, in the current version, MQTT based communication. We are also trying to improve VIS V2 together with Covisa, to also cover the use cases for the future, because VSS V2 is already some years old, so we are striving to get a newer version which covers, of course, also the new requirements we have in the automotive industry with respect to security, for example, and for the concrete protocol encoding, so the payload encoding. I don't know whether it will stay with MQTT based, which is then also using REST, or whether it will go into another direction. I cannot answer that right now. So this is where our experts will look into it. Yeah. Hopefully that is helpful. There is one question. Hi, you mentioned that AUTOSAR roadmap has also medical, industrial, and other markets. Can you elaborate on this? And wouldn't it be out of automotive focus? That is a very good question. Thank you very much for that question. Of course, the focus purpose of AUTOSAR is automotive. That doesn't change. Yeah. The derived applications, simply in the past we had like a blacklist of industry where you're not allowed to use AUTOSAR. And we got a lot of questions as a standardization consortium. It's not on the blacklist, but do you think I can use it in this and that domain? And based on this question, we started to think, okay, why should we not actively, where we know that partners of us have some success, allow it and say whitelist to say, okay, it works. Yeah. So what we will not do because of this other industries is that we will do something specific for medical, specific for industrial, specific for other markets. The intention is if the AUTOSAR standards can be reused as is in these industries, this is totally fine. Yeah, but there is no intention to create something specific for these industries. But we know that certain aspects and a lot of aspects of those can also be reused in the mentioned industries.
Michael, I have a few questions from the audience as well. So I'll just, one of the questions is, what is the basic difference between this functional architecture and also the zonal architecture? These are two confusing terminologies which are interchangeably used. Can you throw some light on that?
Functional architecture and zonal architecture?
Yeah, functional and zonal architecture, yeah.
So most likely this logical view, I would assume, yeah.
Mm-hmm.
So this is a logic view which is not viewing any hardware setup, yeah, because this is only looking at it from a logic perspective. Which logical building blocks will you need to create an SDV? At the end, of course, you need to take these building blocks and apply them to hardware. Yeah, and as we might know, not one hardware might be able to solve each logical block alone. So we most likely will deploy those logical blocks on several hardwares. And the setup of the hardwares, the wiring, the ECUs, etc., this is the zone architecture. Yeah, because at the end of the day, you are placing physically the zone ECU in a certain zone of your vehicle, and you're connecting all sensors and actuators that are close to that zone ECU, yeah. And then you are abstracting on that zone ECU the sensors and actuators to the service-oriented domain. The benefit of the zone ECU, or the original intention of a zone architecture, was to get rid of weight and copper costs, and to also manufacture the wiring harness automatically, because in high luxury cars and also middle class and low end cars, it is still to a certain degree necessary to manufacture the wiring harness with human beings, yeah. Which is also a potential error source, and which also needs some additional quality measures. So the origin of the zone architecture is a very physical origin, yeah. But a consequence, a potential consequence from a logic and software perspective, is that you can take this zone architecture in such a way that you put all of your sensors and actuators which you have here into service interfaces to that domain. So you're exposing like your sensors and actuators to the spine that we have in the back of our body, the human analogy, so that then the cognitive functions in the vehicle controllers, like driving maneuver decisions, etc., yeah, are done then here, and you can take those functions and you can apply them, for example, you did a correct abstraction of your sensors and actuators, you can apply these functions here in all of your different brands, in all of your different models in an ideal world, yeah. So that is the intention, yeah. And of course, that means that if you want to update your cognitive capabilities, yeah, as a human being, if I want to update my cognitive abilities, I will learn, yeah. For the vehicle, what you will do is you will flash those two ECUs again, but only those two ECUs, not the other ones, because your mechanical system, your fingers, your skin, everything stays the same. You're not getting magically additional sensors and actuators if they're not built in, yeah. So you have also a decoupling via the zone architecture from your sensors and actuators to your cognitive domain, yeah. Any other questions?
Another question is, yeah, there is one question. Are the vehicle ECUs, zonal ECUs placed underneath the seats during homologation? That's on the chat.
I'm too much of a software guy that I know where that will be physically placed. I'm sorry about that.
Yeah. And there's another question. In the future, do you think SDV will also follow the zonal architecture?
I think SDV on a zonal architecture has a lot of benefits. So I think that the zonal architectures and SDV will be best buddies in the future, and it will be because of the goal of the software-defined vehicle activities, and a lot of activities we see, decoupling of hardware and software plays an important role. So that, of course, pays into the zone architecture, where you're abstracting your sensor actuator world, which you have here on your zone.
All right. And one last question is, what is the strategy for AutoSAR to work with other forums like, say, Eclipse SDV? Is there something online?
So we have announced this SDV Alliance, and this will be our vehicle to work, for example, with Covisa, Eclipse, Sophie, towards a joint SDV proposal. Yeah, and the collaboration is relatively simple. So we are in constant exchange with the leaders of those consortia and also other consortia we are identifying where we have interfaces. So where we have interfaces, we need to make sure that those are as much as possible usable by the engineers outside, because the engineers outside won't care whether it's AutoSAR or Eclipse or Visa or whatsoever when they need to apply the SDV. Yeah, they need something that fits together and not something that they need to fit together on their own. Yeah, that's our main motivation talking to other organizations, that we are understanding where we're interfacing and that we are making these interfaces as compatible as possible. And the SDV Alliance is has basically three main goals. The first goal is to create a common definition of software-defined vehicle and which technologies we understand under software-defined vehicle. Based on that common definition of the software-defined vehicle, mapping the technologies that exist in these four consortia to this definition of the software-defined vehicle. With that, identifying gaps, identifying overlaps, and treating them accordingly. And then, of course, make those technologies which we have then mapped the SDV compatible to each other. So instead of feeling like a big puzzle to solve, more feeling like a monolithic approach towards a software-defined vehicle. That's the intention. We've just started the work, so there is still a lot to do down the road. Yeah. So we will see how successful we will be with that, but there is a clear commitment of the four consortia to go in this direction.
Fantastic, Michael. And that brings to us the last question. What, according to you, is the definition of SDV?
That is a very good question. Software-defined vehicle is basically very hard to define, but at the end of the day, the term software-defined is, I think, the one that will basically guide us in the future. So we will have, and I like to take an analogy to the mobile market. Yeah. Before smartphones were a thing, yeah, there was basically all of these phones. They were called feature phones. So what was the meaning of a feature phone? A feature phone was a phone that was built, was delivered to the customer, and the customer had always the features on the phone as it was built. There was no way to update these features as a feature phone, right? And then approaches like Apple came around the corner, yeah, which created a smartphone, yeah, so a phone that is basically hosting a environment where you can put any application on top of it. And it's what's currently happening in the automotive industry with a software-defined vehicle. It's the same thing. In the past, we have delivered feature cars. And with a software-defined vehicle, we will need to build cars that are able to act like similar smartphones as smart cars, yeah, where we can also update them applications later on, add applications later on. And this defines to a certain degree the hardware setup, the homologation processes, the cybersecurity stuff. And that's why it is called software-defined vehicle, because this thinking of adding software later gives some constraints on how you need to set up your vehicle architecture. And that's for me the most maybe understandable definition, maybe not the most precise, but the most understandable definition of the term software-defined vehicle. Also looking into the analogy what happened in the mobile industry, because we're in the same disruptive situation right now in the automotive industry.
Sure, Michael. Thank you. Thank you so much for this very informative and very thought-provoking session. It was really a blessing in disguise to have you on this forum to have some of those very interesting thoughts to be cleared by the person who decides. I mean, a person who heads the standardization process. Thank you once again, Michael. Thank you so much for joining us. It's a pleasure to have you.
Thank you for the invitation and wish you all a very good day.
Thank you. Let's move on to the next session. The next session, we have a very interesting personality, Mr. Christian Hustle, a good friend of mine. He's the general manager at Star Electronics. Star Electronics is actually a supplier of network equipment for automotive industry and an engineering specialist in automotive bus systems. The company focuses on rapid prototyping and cost reduction of test environments for remaining bus simulation, gateway, and signal manipulation. This is some of the areas in which Star Electronics works. And Christian Hustle is a general manager at Star Electronics. He's been working with, before that, he has worked with several locations for Toyota, both in Europe and in Japan. And during that time, he was participating in several consortia locally and worldwide for the automotive industry. And he was also managed a lot of projects in Japan. He has an engineering diploma in automotive technology, as well as an MBA in general management, and was working further at European automotive suppliers, different European automotive suppliers in test centers and sales organizations. That's a quick introduction about Christian Hustle, a very passionate engineer, automotive electronics engineer. We are very happy to have you, Christian. And Mr. Christian is going to talk about rapid prototyping for ECU testing, virtual and a real-time environment. Thank you, Christian, for joining us. It's a pleasure to have you, and over to you.
Thank you very much for the introduction. I hope you can hear me.
Yeah, loud and clear, Christian. Please go ahead.
Perfect. And I hope you can see my screen already, rapid prototyping for ECU testing.
Yep.
Perfect. Okay, thank you very much for the invitation. And thanks to all for joining this session as well. I will bring you to this topic of rapid prototyping and have a look to virtual and real environment. At first, a little about me. So you see here, additionally to what was already told, my contact data. So I go through, you will find it again at the end of the session. So no problem if you can't write it as fast. The agenda for my session today. After a first introduction, I will show you about rapid prototyping by us. I will show you some of our products in the area of solutions for gateway and ECU testing. I will go especially to the topic of virtual device, as you discussed today a lot about the software-defined vehicle. Anyway, also our products in general on hardware are used very often in this topic. I would do a short demonstration of our configuration tool to show you how easy it is to create. I will go especially into the topic of replay, give some technical background. I assume today you mainly want to hear technical background. And I would give some information about Star as well. If we don't have time for that, no problem at all. Feel free to ask your questions in between. Yeah, Star, if you ask what company that is, mainly I would say it's a consulting company, but a part of standard consulting, whatever you expect from that. We have a lot of experts directly working in electronics, engineering, IT, logistics, and media. And we are very proud of interdisciplinary solutions. Regarding rapid prototyping, you see here a very short outline. In general, we started many, many years ago with bus interfaces. But of course, our customers step by step came and said, well, can't you do more? Just using an interface and then programming takes time. And so over the last 15 years, more than 15 years already, there was created a solution for RBS, gateway, signal manipulation, visualization, logging and replay. And basically, we sell it all over the world for all OEMs. My first topic I go in is the rapid prototyping. What does it mean? What's there available as a measurement and simulation tool? And if you don't understand this picture here, no problem, you will see soon. At first, let me start with the basics. You all know about cars. I think you are familiar with the car networking, but imagine you have available, whether at an OEM, a supplier, or if you're doing only services for such companies, somewhere a mass production car, like this black one. Inside there, of course, you know, there are a lot of ECUs connected with bus systems. All these sensors and actuators are available, and there might be a central gateway. There might be some different solution, as you have seen in the session before. But your task could be to test an ECU. If it's a complete ECU, you have to test. If it's only a short algorithm, doesn't matter. You are working for the future car, here the green one. And inside that car, of course, all the ECUs are available. Now let's assume are already available, so in some status. Let's assume you want to test the radar system. This means to get this running, you would need to connect all the bus lines we have seen of the mass production car. But you know, all these ECUs are available, as I mentioned, but not yet perfectly tested. They have small bugs, big bugs, maybe no bugs, depending on what stage they are of your development process. And therefore, if you connect all of them, the typical problem our users report to us, then you have a lot of error messages. You need to solve that. You need to find the root causes behind. You need to find a way the system works so much that you can really test your development, your DUT. So therefore, most of you, I assume, do something like this. They separate the radar system in a simulation environment and test it at least the first time there. So for our customers, they go with connecting it to a flex device, taking our configuration tool and the databases of this future car. This database is opened in the configuration tool, and all the available information you can then summarize in the graphical user interface and define what you would like to have it doing. At the end, you get a lot of automatically created code when you start the build, and then you flash it on the flex device and the RBS is starting. So this means now your radar ECU goes into active state and you can now test your equipment. Whether it's the hardware, whether it's a single software, whether it's the final testing, it doesn't matter. Anyway, not everybody is happy with this testing. You know, this might be a first stage, but a simulation is never as exactly the same as the real world. So the second step you want to do might be the gateway testing. So you need a real environment. This means take again the flex device, take again the databases of the future car and the configuration tool, but this time load additionally the database of the already existing mass production car, use all the ECUs which are there in such a car, keep it there, again, create the project, build the project, save it on the Flex device, and from that point, you have the Flex device acting as a gateway. And so your complete system is available and you can do the testing of the radar system. This means it can be a complete car like shown here in background, but it could also be a single test bench with just a few ECUs or a very big test bench with all the ECUs. It can be the arrangement of an individual developer at his desk. It doesn't matter. What does this mean? What's the result out of it? Well, you see here, you have the mass production car, and for testing new equipment, very often it's the easiest case just to replace a part of it. You see the mechanical view, you see here, well, something is wrong. It doesn't fit together. You need to care about this gap between the two architectures. And of course, we are focusing here on the software side, the technology side, or we especially about the data side. So it means we take the Flex device and bring it in there for an translator or simply as a gateway for adapting the data between both sides. So if you are working in this area, the Flex device might be the perfect solution for you. Maybe you already use it. What's the innovation? Why do we use this? Why do you need to use it? Well, it's not really perfectly new as the tool is already existing for 15 years. But one main advantage what our customers tell us, they can avoid computer systems with a long startup time. The Flex device starts up at the same time as normal ECUs. So this means with, for example, using a computer with two interfaces, you would need to get in the car, turn on the power, wait for the computer, the operating system, wait for the project software, and so on. At the end, you start your car. With the Flex device inside, well, you get in and turn on the car as usual and start your testing. A second reason is you can avoid a specific solution. I assume you all know about how often you have to create a completely new equipment, especially for testing. That's not necessary with the Flex device. You can save a lot of development time. Now let's assume you only need to have a software for an ECU a tier 1 delivers. Well, if the ECU of the tier 1 fits to this layout here, has enough interfaces for the left and the right side, it might be perfect from hardware side. But then you need to program the software side. You know it takes time as well. You might need some rounds for bug fixing until it works perfectly. When the bug fixing is finished and it works, it might be from OEM side, there is already available a new database. So you need to update the database in an existing project, maybe manually. So therefore, it's a big advantage here with the auto code. Yeah, you just load the new database and the tool adapts it automatically and you do the necessary changes and then you create the software code necessary. If you need to create a completely new hardware, well, You know, it takes even much more time and much more money. Let me go ahead and show something about this rapid prototyping environment of us. I have already shown you two features inside the tool, the RBS and the gateway. You see here the basic steps behind. Well, basically, I have already explained them in the former slides. And there is additionally also the possibility for you to manipulate signals. There is the possibility to visualize data on Windows computer directly with the tool, or there is also existing a mobile version, especially often used for visualizing of the data and, for example, passing around the tablet with a lot of visitors going through a car and want to see the details, how it works and if it works. Then you have the choice of logging of data, logging directly on the Flex device, micro SD card, and later on you take it and go with to your computer and use the data there. Or maybe you simply want to log it on the tablet app. That's possible as well. Then we have a feature replay. Replay I will show you in a later part of this session. And we additionally have a feature called user function. As we have a lot of customers in the area of own equipment they provide, let's say testing houses. So they want to adapt this equipment to their test bench, to their own equipment. And here it's possible to write C code to adapt it, for example, with UDP data exchange without using a specific API of us. They do it themselves. But also you could simply want to add a feature which maybe in our graphical arrangement here of the total tool is not available. Well, simply write it. And also we have a lot of customers doing their testing of software functions, the algorithms, on this Flex device. Well, it's a prototyping hardware. If your hardware, the prototype is not yet available for testing of your algorithm, you could bring it in here and start the testing before the prototype finally reaches you. What's the process behind? Well, I mentioned already a little, but let me show. Well, at first you do the input with bringing in the databases. You use the tool FlexConfig, create a project, do your arrangements mainly in graphical user interface. Then you build the project and flash it to a configuration file and flash it as a configuration file to the Flex device. On the Flex device, then you run it unlimited, whether on one hardware, whether on 1,000 hardwares, whether one time, whether in a long-term testing for 1 year, by connecting to your DUT and maybe more of the environment you have in a test bench or in the car. If you need, you create the access to the mobile version, for example, to visualize the data that is already available in the Flex device. If there is a question, feel free to ask. Otherwise, I now start with the topic of virtual Flex device. Virtual Flex device, you see here some use cases. Well, the basic one I have shown you, that's already existing for more than 15 years. Out of the project, creating an executable and run it on the Flex device. But time by time, people come and say, well, we don't want to go to hardware. We need it on a computer, for example, on Windows computer. Linux would be possible as well. And there we create an executable. So you can do this by your own, or you've defined you want to have a DLL, because I mentioned here one supplier digital work with an automotive data and time triggered framework, but you could use it with any other tool chain as well. The use cases are, for example, a simple gateway, not like we have seen before with the Flex device in real, but having a log file based on an old communication matrix, let's say the former one, and it shall be transmitted into a new log file on a new communication matrix. Maybe a new bus introduced, maybe not. That doesn't matter, it's available. Well, then you have the virtual Flex device here, let's say, as a conversion between the old and the new log file. Quite often, this is used in cloud. So if you use that, if you have part of it in cloud, if you have it completely in cloud, well, feel free to contact us for the details that might be adapted for your arrangement. Basically, I would say we are an engineering company. We get it to run. A second use case could be the manipulation. Well, whether it's here the log file or not, doesn't really matter. But this means you change the values. You have to adapt a value because of in the new car, it's a different subset of parameters, whether it's to have a completely different range. All of this you can do in the signal manipulation. Next, it could be you need a real environment to test your software, a single algorithm or a complete software stack. It doesn't matter. Whatever you have, you can connect to the virtual Flex device, run it there. And for example, by CAN, you connect it to the test environment. Of course, I used here our Flex device. You might have your own, and connect it there. And for example, in the external environment, you adapt data, or you simply provide the results, whatever the algorithm you test needs to follow on with its operation. Next, it might be your application is the test environment. You have your own environment, you use an interface, but you need to proceed with the next bus, for example. You need to adapt it. Well, use our virtual Flex device, create it as a project, use it in your development computer, connect it with the test environment, and then connect it to the DUT and go ahead with your testing. Benefits for you, I show here. Well, behind the DLL, it's C language. You can use it virtual with different use cases, just for adaptation between different matrix, as you have seen, or manipulator as gateway. You can even convert the projects to a real device, or the opposite way. So it doesn't matter on which way you have started. Then it supports many different buses. It's integratable into various frameworks. And if needed, you operate it in the cloud. Standard, well, you do it on one computer. The process I wanted to show you from the perspective on how could you use during progress of your testing. Well, maybe you start with the log file conversion in a very early stage. You then move forward and use the log file for communication through one of our interfaces to your real ECU. If you need this way the log file, or if you do it directly with the virtual device, doesn't matter, both is included. Then, of course, you also can use later on the project with the Flex device in real. You might have your prototyping car, the mass production car, equipped with some new ECUs. You can use it in the final car only for manipulation. So all the ECUs fit together, they can work together, but you break a bus at a specific point for being able to adapt signals going to the real ECU in order you can test corner cases. And I mentioned the adaptation. So if you start, for example, in the virtual device, you can say change device type in the tool directly, and the project is converted, for example, for the Flex device L square here. If it happens that at a later status, you need less buses, for example, and you want to use a smaller hardware of us, maybe the bigger reason is a cheaper hardware, well, do it. You can convert in any way here. Also, you could start here if you at first work here and say, well, it's a perfect tool, I want to use more. You can go also the way back. Some products behind. You see here the product families. The Flex device family is what we have already for decades. That's available, and it's the solution on hardware side for the Flex config, the configuration tool. We have extended in between with our Flex systems for, let's say, smaller applications, the very small hardware, Flex System XS, or the Flex System M for the very high computing areas. So typically needing a lot of automotive Ethernet. And then around that, we have the switches. So not all the time you want to have the switch inside the Flex device, or you simply need a switch and nothing else. Well, in any way it's existing. We have tabs. So just as an interface, let's say, plugging between a working Ethernet communication line and then accessing it by a computer. Also here, we have simple interfaces on media converter side, or the interfaces for several different bus types. So let's say each Flex device is existing as a simpler interface as well. The Flex device, the Flex system is what you have seen before in the rapid prototyping environment. The Flex interface is the interface for your own software. Let me simply show the Flex media and mention it could be used as an interface like here with the virtual device on the computer. That's one use case, but of course it may be also your own application, whatever you have there, completely independent from our software side. Then let's go to the Flex device family. Don't worry, I won't show you all the details here. We are not doing a sales presentation. Yeah, you want to focus on technology. So the Flex device is basically an ARM Cortex A9. And it's very flexible as we have 5 slots where you can choose the physical layers you want. So for example, the typical solution our customers want to have is CAN-FD plus Ethernet plus FlexRay and maybe some LIN and send. But sometimes there are completely different requests, only CAN, only Ethernet, or maybe some smaller systems like K-line. It happens. The Flex Device L is a little smaller hardware. The Flex Device S in this product family is the smallest and has more completely fixed, but also some options to add additionally depending on what buses you need. Then there is the Flex Device PCIe and PXIe, which you can use into your own hardware environment. So like with a graphical processing unit, here you would have an additional hardware giving some more performance into your system so that the computer tasks don't need to care about data. Very important for several buses. Maybe with a CAN, you never have problems. With a FlexRay, it's something different. You need to bring data traffic all the time. A delay is not possible, for example. Then the Flex System, our newer product line with the high performance environment Flex Device, Flex System M. And in there, it's a lot of options that you can plug in. So you can also plug in Flex devices and interface cards. You have the possibility to use SFP modules. And of course, it's Wi-Fi integrated. And by 1000 base T, for example, you can use the configuration and run it. Then the Flex System XS squared. This is the smallest system we have, the smallest device we have currently, with 2 CAN-FD, 2 LIN, 2 send. In this arrangement, it's also available with only one of it as a Flex System XS. And for example, you have there an option to use an LTE module additionally. Flex in general, what we have there as products behind is engineered here at our location in Göppingen in Germany. You have a lot of changeable physical layers, a fair and flexible license model. And for example, we adapt also to your needs whenever. I show you a very specific use case. It's not the standard running everywhere in the world, but well, it's something you might need. For crash tests, for example, if people need to observe what's happening in the battery, well, they put the Flex device in the car. When the car is crashed, they observe the data by wireless. And once it's finished, they check if all is fine. If all is fine, people may go there and analyze the battery optically. And at the end, typically the battery goes into a storage where it's observed, for example, for another 2 weeks. If nothing happens, maybe it can be reused. Well, that's decision of customer side. Now I go to the replay case. Replay has been used by many customers without any problem for CAN and FlexRay, for example, over years. But especially with automotive Ethernet, so for handshake mechanisms like SOM IP, they have problems. You cannot simply replay the data. here, then it doesn't work. The ECUs don't connect to each other, and therefore the replay must be adapted. So we do it in the way that the payload comes from the trace file. It's integrated then in the total data area, which means the header has to be added, the time sync information has to be added, the handshaking has to be added, maybe done before, of course, before the replay starts. Then content of simulation and gateway, you could also integrate. And especially the security information, whether it's a simple CRC, whether it's SecOC, end-to-end protection, all this has to be added in the necessary way. Then it can be sent on the bus. Well, and if you need, you can also integrate a manipulation, as we have seen before for the tool in general. A use case is then, for example, you have a recording based on one matrix. You use the flex device and deliver the data based on another matrix. If you say you don't need that, you have the recording at the same K matrix. Well, use it. Use it in the way it's existing and fitting, but maybe manipulate the data here. You choose it directly in the software. Before I now go to the network technology background, I would say I go to a live demonstration of the tool. If this fits, if you would say, no, it's not necessary, let me know. If you have questions, let me know. Otherwise, I start here with my tool. You see here the main window of the Flex config. You see on the left side a device manager that remembers all the devices you had connected in the past. For each of these devices, if you click on there, so for example, let's go to a Flex device L square. You see some information. What device type is it? What IP address is it? What physical layers are integrated? What licenses are in there? Then you can do some settings. So for example, the IP address, the termination of buses, and settings for sleep and wake up. You can then go here, for example, to the logging, especially in a diagnosis page. And on the bottom, you see the output. If something is done in background, for example, the build process, you hopefully never see some error messages here. Otherwise, you go here and check what might be wrong in your total setting. Then, when starting with a new project, here you choose a Flex device. So for example, a Flex device L square in the standard configuration, like it's typically requested. Let me simply start with that. The screen changes. You see the Flex device here in a graphical representation on what buses are here connected or available on the 5 connectors. And we go, for example, and say, I add a FlexRay bus. I need to choose a database behind. I show you. Where is, oh, here. I have to choose a database from here. The FlexRay I take. It's then converted for internal understanding. Once it's opened, you add it, and then you can do the settings. Sorry, I'm working with two screens here. You start here the operation by the base settings, which means some basics behind the bus. You see here the information on the database. You do the simple settings, like, for example, you want to simulate one ECU. The result the tool gives you automatically is a list of frames that have to be sent on the bus for this arrangement. You see, it's a very simple demo database here, so don't matter, it works with your big ones as well. You can do settings for end-to-end protection. You can do standard signal handling, like, for example, I choose a header file with the CRC. I choose a C file. By the way, all of this is integrated automatically depending on what OEM you want to work for, or at what OEM you work for, as we have their specific packages. And then you add it, which means, well, you want to use a prefix. Maybe the prefix CRC underscore is needed for any signal starting with CRC underscore. Then this function shall be used and these parameters shall be given. So now it is executed for any of these signals fitting to these conditions, and the result, the final CRC, is then sent to the corresponding signal buffer of the CRC. For FlexRay, you have the chance to do some offset settings here for gateways. I have not yet created a gateway, so it's not useful at this stage. And especially for Ethernet, here you see a lot of additional information which you might need to adapt for your test environment statically. All of this is to be found here. I leave it. I use another bus, maybe a simple CAN bus. I go there, select a database. I need this time a CAN database. I choose a simple one, convert it again, and work with it. You see, you can do the same arrangement here. This time for CAN bus, of course, completely different content. This time, maybe I take the opposite of before. I use the ESP as a real ECU. I want to connect on the other side of my gateway. And the result again is a list of frames that are needed to be sent because of the receiver. You see here, the original receiver is the CESP and the original sender is the C steering. You can adapt this list manually, of course. You can increase, you can ignore some frames, whatever you want. Then you have the arrangements of a simulation, and you could go now to build the project and flash it on your hardware, or if you created a virtual device, of course, to the virtual device. Let me go to show shortly about the gateway editor. In the gateway editor, you see here all the data behind. Now my Zoom screen is disturbing a little, sorry. It works. You see here on the right side the TX information, anything that's to be sent from side of the Flex device. And on the left side, you see here the source information, meaning all data available in the different buses you have connected before. Now you could simply say, I want to connect wheel speed. The tool shows you what frames, signals, or PDUs might fit to whatever you have chosen here. In my case, it's no perfect fit. The information of FlexRay and CAN is different, but it might be this one you want to connect. So do it. You have here a choice to adapt data. You get the possibility to choose several source intervals, to use linear functions. If there is defined some scaling, some functionality between raw and physical values in the database, it's used for this calculation. However, it might not be found automatically depending on what you want to do. This was a simple case. Maybe you want to care about intervals that are not yet used, giving maybe just some fixed value, or maybe deleting the negative values. Maybe you want to give here some maximum. Of course, it fits to the number of bits you use in your database. But you could also use something completely different. Sorry, I don't know if this makes a sense. Maybe a lot of people of you say, never do it. Doesn't make a sense. Let me simply use a steering angle to copy it into a wheel speed. Well, do it. Tell the tool what linear function or what fixed value, whatever should be used for the different source intervals you might define by yourself. Use it, do it. That's the operation you can choose by yourself. On the target side, I have here 16-bit. Maybe the outcome is wrong due to a different arrangement of bits and how the data has to be converted. So therefore, observe about this. As long as you have errors here, it won't work perfectly. That's the simple steps how to create a gateway. In the same way, you can define signal manipulation. I go there with you just for a short view. Sorry, on wrong screen again. And I simply take wheel speed 1 by drag and drop. Then the manipulation was created. And on the right side, you do your settings. What method would you like to do? For example, an offset, a drift, a fixed value. Would you like to freeze it on the last value? Do it. Define some parameters and start it. If you need more than one signal, create a sequence, create the manipulations you need, and drag and drop it there, and then save to the device and start the operation. This start button is for a single operation, as you have a direct line to the Flex device. This save to device and start is for long-term operation. So whenever you take off the power of your Flex device and reconnect, all these manipulations start again. So you can really work with it as a standalone device. I keep it as it is and go back to my session for technical background. Feel free to ask for questions in between. I hope you see my screen, otherwise let me know. Yeah, we as an engineering company focus a lot here on the real problems our customers have. And you see here at first a simple example of FlexRay. You separate one ESP from the complete car. You need to test, for example, for corner cases. by changing of data, so for a signal manipulation. This means, well, do the arrangement with your flex device, use 2 different buses, and both are connected here to the host of the flex device, and test. It might be a problem of your arrangement that this ESP is not a cold starter. In that case, the arrangement like this doesn't work. Doesn't matter. In the system, we have the possibility to use a second communication controller. This means these 2 care about cold start feature, and your non-cold starting ECU can integrate later on existing communication. The same if you need for the other side. Maybe here with a complete car you don't need, but you could have a different arrangement. It's not necessary to have a complete car. Then also with FlexRay, there is a topic with synchronization. If you do a gateway, you need to care about synchronized information flow. If you don't do, you might get frame losses. If one bus is faster than the other, at some point, there is maybe from the side of the first bus, data missing to go to the next, we call it the slave bus, because of the slave bus is faster, has one more cycle, or especially one more round already done. So there is no data for that round yet on the master side, how we call it. Therefore, we can synchronize between both like this. So it means you have an offset between. In a standard FlexRay, any participant on this slave FlexRay can't notice it. Here it's the cycle is given, the data is there, all is fine. Be careful if you have at a later point after some operation data necessary to be sent back on the master bus. Here would be your original position. That's not possible for that frame. Here you would need to go back in time, as it is exactly here in this case the 2 cycles later. So maybe it's the perfect position, the perfect slot to put it in here, 1 cycle later. But that depends on your arrangement. Therefore, we have different offset types where you can care about cycle or even the round. Don't forget, the way back is never possible, independent of how short you do this offset. At least you have 1 slot that you need because of receiving data first with such a signal manipulation. Then going to automotive Ethernet. Well, you could have a car, need to test the ESP, and inside the car, there is a switch with an existing or a free port. This means you could need to use simply that port. Don't forget, it's not possible with that to do a complete mirroring, as for example packages with CRC errors will never be transmitted by the switch. Or for example, you can't do a signal manipulation. You can't interact with a simple switch for exchanging data. Therefore, we have as well the possibility in our Flex device to integrate tapping. So like that, you have here a connection with 2 bus drivers in an existing bus line. They exchange data as usual. And with this, you have direct access to any communication. So including the errors of communication. Another option we have integrated in our tool is a physical layer with a switch. I don't show all the details here behind. That's here what I focus on, but it means you can communicate directly via the switch between the ESP and the rest inside the car, or you can communicate through the switch to the host and from the host then to the car, and the opposite way, of course, as well. So like that, you have the choice with former configuration to access some data and exchange it even. There is also a possibility for having two independent buses. In fact, this is the solution we see most often requested. Like this, you have access to anything in the software and can adapt. Like this, you can also use different IP address rooms, for example, which is not possible with a simple switch or a tap. Then we have provided an API where you can work with your user application to adapt the data of the RBS to influence the manipulation, the gateway, or the user function. You have the choice to use UDP exchange defined by yourself without our API and do the same. The communication in both cases is here with a standard Ethernet between computer and the device. Or let's say this is a very early way people used, but today, because of automotive Ethernet and knowledge of Ethernet at most of our users, it's not used anymore so often. So you can simply have a CAN interface on your computer. And with the CAN, by a normal RBS, meaning an interface, you can take CAN data to influence anything else. You could also, for example, say the data coming here from FlexRay, you give 90% to the other side and opposite as well, but 10% you deliver to the computer, and 10% of the new communication for the other side comes from computer with some algorithms behind. Then SecOC is integrated. I assume you all know about. I won't tell details behind, but it's available as a standard. And it means you might have a simple configuration with data going through the gateway, which means basically nothing is required by the gateway. It's simply adapting the data from two different buses maybe. But if you need to manipulate or regroup data, no problem. In this case, use the SecOC MAC generation of the gateway side, and the data is adapted so that finally the MAC verification at the target really works. Then it could be you have a car as a basic car behind the prototyping that only delivers data but doesn't have an algorithm for SecOC. Well, no matter. You can test the radar ECU with its MAC verification anyway. Simply deliver the MAC generation from the gateway side. Also, we have integrated time master functionality, especially if you have several subnetworks connected to each other and define the Flex device as a global time master, or synchronize to an external device, maybe the computer, or here in this example, the ECU. I'm through my presentation for technical details as well. Here you see a summary on your advantages, and I hope you will ask some questions. If needed, I can go through the information what's star, but I would say I'm finished here. No questions so far, I heard. Therefore, let me just say, we integrate new standards all the time. And if you bring new requirements, just because of you need a use case we haven't had so far, feel free to mention. We do it as soon as possible. And if you need us just for a tooling supplier, we are happy. If you need us to realize your gateway, we do that as well. Or we can give training. Training for Ethernet, training for the flex config. Feel free to mention whatever you need. So now I would say, let me know if there is any further question or if I should go through information of star. I assume the next session starts. I don't hear anything so far.
Hey, thank you so much, Christian. Thanks so much for joining us, and thank you for giving us a very detailed account of what the tool can do, and also giving us a technology background on how the tool is able to realize some functionalities. Thank you once again for your time. We'll take a quick we'll take a quick tea break, and we'll resume at 4:10. We will get on with the most interesting session of the day. And we will have a speaker from Electrobit, Mr. I'm sorry, Umesh, who will be speaking on
Christian, thanks for your wonderful session.
You're welcome.
Hello? Can you hear us? Hello? Hello? Bhishma, can you hear us? Hello? Your participants will be muted them. You can't. Okay. We will start in 1 minute. The call is getting arranged. 1 moment. Okay, let's get started. Before we get started to the next session, a quick announcement. We have here the auto cluster team. We have the auto cluster team. The auto cluster team has been the sponsor for the venue. We thank auto cluster for giving us this opportunity to host this show here, and also for all the support and all the facility that has been given. Thank you for your hospitality, sir. As a token of appreciation, I would love to request Arpit from Yellow Matrix to honor our auto cluster team. And before we move ahead, another round of announcement. It's been a honor, and we are really happy to announce our first innovative product into the market, an open ECU. And we are even extremely glad that we have our very old friend partners, and even we could call our associates, the whole EV team here, who will be unveiling this open ECU to the automotive industry. May have Umesh and Sachin please come and unveil the ECU with our CEO, Annamalai. Yeah, Kunal. So thank you, Electrobit team, for supporting us. Thank you, Kunal, and thank you so much. So this is an open ECU that we launched into the market, and it's based on S32K144. And any automotive company who would like to start building a product or lightweight ECU, because it's an S32K144, could pick up this ECU and start working on it. We also provide a CAN and a UDS stack from ANCIT for you to get started to build this ECU to start with. Yeah. And Malay wanted to add that this will also be India's first ECU, which will be available for training, in the sense you will not have to learn automotive electronics with the evaluation board. You can start learning automotive electronics with an actual electronic control unit that will be deployed in the car. So on this note, thank you so much. It's really an inspiration to work with all these young engineers to make this happen. And thanks to all the inspirational and leadership team from ANCIT also for this. Let's move on to the next session. The next session is one of my favorites, and also one of the favorite sessions that most of engineers in SDV are looking forward to. It's about unveiling the power of automotive OS in shaping software-defined vehicles. And no better person to talk about it than the product manager from Electrobit, Mr. Umesh. Umesh is a product manager in Electrobit heading the team in Bangalore. He has a wide range of experience working with various automotive OEMs. He was also formerly associated with Emphasis and KPIT. And right now he is responsible for delivery of most of the many product lines in Electrobit, delivering it from Bangalore. Thank you so much, Umesh, for joining us. It's really a pleasure hosting you. And I'm sure you'll be overwhelmed with a lot of questions today. Thank you so much. Yeah.
Thank you. Good evening, everyone. So first of all, it is really happy to see a product coming out of ANCIT. And I remember when we started this partnership, we were trying to understand the AutoSAR together with them. And then today, on this day, I see that a product is coming out from the ANCIT. I wish many more successes from them, and then we will see a lot of good work being done by the ANCIT. Keep up the good work, team. Okay. So at the same time, let me start. So there are two buzzwords in this session that we have been talking about. One is the SDV and one is the automotive OS. And when you come as a last speaker of the day, a lot of your ideas or a lot of your points on the slides are already covered by your predecessors. Now, how do you keep engaging the audience is a challenge, right? So I will not get into too much of technical things here. Try to summarize what is SDV in nutshell, and then I'll talk about the automotive OS a bit, defining what automotive OS is, and then a value stream of the automotive development, how it covers the automotive OS, the business model that comes into picture, and then how it generates the value, and finally the customer delight. So keeping this as an agenda, let's start with the first session. Okay. Slide doesn't move. So there is a small video.
on the
It's fine.
how you can play it on your mobile.
So this was just a bit of what Electrobit does. And people on the call were lucky to hear the audio, but people here were not so lucky. Anyway, I'll share the slides. Probably can view that video later. Okay. So we talk about the SDV stuff, and then we have to move into a new segment or a new model, business model. But why? We have been developing the cars for so long, and then we have been successfully delivering the cars also to the customers. But why are we now thinking of a new business model, right? So if you look at the statistics from the reports that come out, right, we see there are around 36% of the cars that will come by 2026 will have the capability to update the firmwares over the air, right? And then from the existing 7% to 35% by 2030, the new cars will have a common software. What does common software mean? So we'll touch upon in a bit, right? And then
Stop sharing and resharing it. We are not able to see the screen in the online.
Okay, thank you. And then by 2030, the software-based features and services will be a market worth of 640 billion, right? So it is just a small segment of 5 trillion that we spoke about, the complete IT segment, but 640 billion will be the worth that we'll see in the market. And then 66% of the OEMs would want to work with a partner software. So this is the trend that is moving towards. And there is definitely a need for moving into a new business model that is a software-defined vehicle. And then also understanding the ecosystem that comes along with these challenges, right? So this is now, what is software-defined vehicle? So many of the speakers just before me have tried to cover. So I would start with, rather than touching upon the features, but let's start with the business model that will get changed. Now, the cars are being sold at a feature specific. What is a business model change? Now we will say software will add the feature. Fine. What is the change in here, right? So this is a basic question. Now, when I sell a car as a feature, I add different features to it over the air over a period of time. The car value keeps changing. Now, what is in it there for OEM? What is in it there for an end user like us who uses the car? Or what is in it there for me as a product development in a software company? What is in it there for the entire ecosystem around us? This is the business model that's going to change, right? First, let's talk about the end user. Finally, we are selling or we are making the cars for us, the end users, to use them and experience, right? So for us, what is in it for SDV? In SDV, what end users are going to gain? I'll just give you a scenario. You have purchased a vehicle paying a premium price, which has a feature which is cruise control mode. And I often drive in a Bangalore traffic. I cannot go beyond 30 kilometers per hour, right? With such a huge traffic. And should I use cruise control in Bangalore traffic? Not possible. But I'm paying the price. Does it mean that I should not buy a vehicle without cruise control? No. Sometimes I want to drive home back. native Belgium. When I come, I want to use that vehicle with a cruise control, right? Now, I am at front paying the price for a feature that is in the vehicle and often don't use it, right? I'm a loser in this case. As a user, I'm a loser. But with an STV coming into picture, the business model that changes is you can enable and disable these features and pay by use. When you enable, you are enabling the feature, means you are paying for it. And then when you disable, you don't pay it, right? So I'm saving on the money. And also, if I have bought a car now without a certain feature, now with the new trend of STVs coming in, those additional features that are coming up in the market, it will open up for the wider market to develop these features, not only the OEMs or not only the software developers like us or suppliers like us, tier ones. It will open up a avenue for each one of us to develop the applications. Like what we discussed in the earlier session, it is like giving an analogy of a mobile phone. There are a lot of features that can be developed. There are a lot of ideas out there in the youngsters now. They come up with the feature. And if I want to add it, I can add it. I can create and increase the value of the vehicle as the end user. So that is the benefit for end user. Now, what is in it for OEMs then? Right? Anyway, they are selling the features. They are available right now. People are there to buy it. But how will this change the sequence or the synergy for the OEMs? Right? So now OEMs can monetize over a period. It is not an upfront sale. You can try adding a feature, and then once the feature is available, push it over the air. It will be available, and customers wanting it can enable and subscribe for it. So the value of the car is monetized over the years. That's something that will be benefited for OEMs. Now, software developers in automotive segment or in non-automotive segment, both are having a benefit here, because software developers, we will have to bring in a lot of synergy between the existing feature specific development to the cloud-based environment, the online cloud-based development environment, virtual ECV environment. So software development in the automotive segment, we are working towards it. Plus, there are software developers who are working on the IT segment. Maybe the state of the cloud, the virtualization, right? The build environment, the CI/CD environment, Amazon's, Google's, adding features, right? So they will also start playing their game, their part in this game, and then together, they will entire development community, the IT community is going to be benefited, right? Now, does it end here? No. The business model will also change with insurances. For example, you have now the vehicles are connected, the vehicles are there is a lot of data that is pushed onto the cloud based. So based on the end users or the driver's behavior, how he drives, I can adjust the insurance premium. If I'm a rash driver, next time I'll have to pay a higher insurance. If I'm riding on a guidelines that are specified, my premium might be lower, right? So this is how the entire synergy gets changed when move into the software defined vehicle, right? Now, so some of these topics I have just spoken. Software will create a value or experience for you, right? So you want to enable, we have already spoken. So there are a lot of use cases that we spoke about. If you want to turn on your heater, maybe in the European countries where it is cold, before they get into car, they want to turn on the heater in the car so that the temperature is ideal for them to get in, and then also turn on the seat heaters so that they can be comfortable. The feature is available. The hardware can be plugged in and we can enable, right? And if any other feature that you think through, any of the use cases that you think through, which is software controlled, can be added into this segment, right? So that is how the value of or the feature of the car is now defined by the vehicle. You want it, you add that customized feature, the feature of the vehicle changes. You have bought one car, added a new feature, the value of the vehicle changes, or the feature gets added, changes. So software is now defining the feature. You want it, add it, subscription model. Right. Then car value also is getting increased. Right. Once you buy a car, usually we see the same set of features that were predefined, pre-configured for us. It is available, and the car, we continue to use it, and over a period of time we lose interest over the car. Maybe it is just a commutation purpose, but now when new features are getting added, you also start enjoying the features, and then the car value in itself is changing over a period of time. And then there are evolving features which comes along with the opening up of the development in our open source environment. Many features that get added, many features which we are not even aware might get added into the vehicle. So the features get evolved. And then it's an analogy that we can all understand. Smartphone, a feature phone that was there with a keypad, with a calling facility. We have also seen the phones with a feature that had an FM enabled embedded in it. We could only play the FM with inserting the jack. And then we saw a smartphone. Now the smartphone is just not a phone. It can be a bank if you just install a banking application. It can be your insurance office if you just install an insurance app. Look at the dynamics of the hardware that is available being used in multiple dimensions, right? So on those analogy, just imagine what could come into the software features as a features into the car mobility. A sensor, driver assisted sensor, you just touch your thumb, door opens, you just scan your iris, vehicle starts. There are many we can think of, and we can just try and understand how it could be with an analogy of a smartphone. That's the intent of this case. And also these are being customized for each one of you. Like if you want a specific speed segment, you customize. You want to enjoy a certain feature of music, can be customized, right? Based on your driving pattern, the vehicle configurations can also be adopted for longer lasting of the vehicles. So vehicle can be customized for an end user. And then we said there could be many coming into picture, a lot of applications that could be added. And all this is going to be possible, or we can seamlessly do with an automotive OS, right? So what is an automotive OS? We'll talk about it later. And then how it can enable the SDV, and we can harness the complete power of automotive OS in shaping the SDVs. Software complexity, why are we moving away from this? This is a graph that shows the complexity that is getting increased over a period of time across the segments, and also the productivity of the different industries. So the bottom line is the productivity graph of an automotive segment, and the dotted line is in productivity of IT segment, and the black line clearly shows the complexity that is getting added. Now, with all this increase in the productivity by 2030 also, we will not be able to meet the complexity with the existing resources. So can I continue to add resources to fulfill this complexity? It won't be a sustainable model at all. I cannot deliver. So how can we achieve this? This is just by opening up for an open source segment, where each one of us contribute our own ideas, each one of us understand what are the features developed by the other segments, and then try to enable each one of us and build this complexity. Why are the complexities changing, or why do you see a sudden surge in the complexity? We will look into this graph. Okay, so any vehicle that we look at will have a standard segment, mid segment, and high segment, right? So based on these dynamics, the complexity of the software and hardware in the vehicle changes. There is also a perspective when we add the brands, right, within the same segment, the same vehicle, OEM, different models, again, low, standard, mid, high range, and then different brands. The complexity is increasing, right? And then you look at the on the right side, you see how the software efforts that are required to fulfill this is also evolving. Now, suddenly you give a configurable options to the end users around these segments, customize their own software. The complexity again rises, right? Again, with all this, the new products that are coming in, new SOCs that come in, right? Every quarter we see one or the other SOC getting added, and there are certain benefits. Each SOC that are being developed are trying to address some of the challenges that we are currently facing. So it is inevitable for us to adapt to the new SOCs. Again, the complexity increases. Again, the same question: can we live with this complexity with the existing ecosystem? Definitely not possible, right? So therefore, we need to move into an SDV environment. Also look at the evolution. This has already been spoken. I will not take too much of time here. I'll just try to brush it up so that the automotive OS that I will be speaking will be connected better. So before we had all the flat architecture, there are custom specific ASIC chips that were developed, or ECUs that were developed to perform the specific functions before 2020. And 2022 onwards, we have the domain controllers, 4 domain controllers, and trying to align and then minimize the complexity of the ECUs and the buses and the software that gets in. Now, today we are talking about the zonal architecture, where my partner in the Continental has already explained what is the zonal architecture, and then how we are trying to align the sensor-specific zones. And he has also tried to map it to the human brain, right? So this is the current state where we are aggressively working towards the zonal architecture. Now, when we come up to the SDV, will it suffice? The zonal architecture or the domain controller architecture, will it suffice our needs? No, because we are coming up with a FOTA or over-the-air updates. There are a lot of applications that needs to be pushed. There are a lot of diagnostics that needs to be re-enabled, reconfigured over the air. So it's going to be complex environment. And that's why the experts in the IT segment or automotive segment predict that we will have a central brain with a high compute power, which will again in turn control all these zones. And then below the zones, we will be having the actuators, the sensors, the other logic that comes in. So we need this high power compute. So the silicon trend that you see over a period of time, it is no longer a single core chip anymore. A lot of chip makers making multi-core with so much of high power capacity, right? So this is all where we are heading towards. And then on the top, if you see, there is a small line which says automotive OS relevance. Now, the flat architecture had its own application, middleware, OS, hardware, MCAL, stuff like that. And then when we are changing these architectures towards domain controller or zone control or a central computing zone, there has to be a lot of synergy, the harmonization that needs to come in. And this is possible with automotive OS that we talk about. right? So all this MCANs, the say complex device drivers, the hardware abstraction layers, all this needs to be synergized, and then also we need to evolve the APIs that could be used, that could be exposed to the open application development environment. A lot of synergy, and again there should be an in-vehicle compute, and then at the back end there should be a cloud compute, which will be tracking your lot of the parameters on the vehicle movements, right? So all this is possible if we have a proper synergy that is established, and that can be possible with automotive OS concept that is being evolving right now. There are a lot of players who are working towards it, and then Electrobit is also one of which we have been leading this at this point in time. Yeah. So this is again a wrap up how the ECUs were at the beginning. It was all flat, feature specific, purpose fit way ECUs. Each ECU controller had its own hardware, OS, MCAL, and stuff like that. And there are hundreds of ECUs. Now, the more and more features that we want to add, there are more and more controllers that we need to fit in. And then it's going to be mess, lot of bus, lot of data transfer, huge bandwidth, right? So that's when the AUTOSAR automotive segment pitched in, and then there has been certain effort put into synergize the middleware, which is common, which we can use across different controllers with little bit of modifications, and then applications can change. So that is ECU independently working towards. And then today we are at the stage where we want to harmonize the middleware and the OS to all the ECUs with their own applications. And then in the future, we will also see, we have, you would have also heard about vehicle to vehicle and then V2AV, V2X, right? So this is also coming in picture. When we ADAS, we are aggressively working towards adding new features, and then new developments are happening in the ADAS area. Vehicle to vehicle communication should also happen. If that needs to happen, then the software that is running on two vehicles, multiple vehicles, should understand one another. Other than that, there is no option for us to detect and work towards the ADAS segment, right? So that will be the future of the harmonization between the softwares. So that is where the automotive OS will evolve over a period of time. Now, all this while we talked about, I just tried to brush up what is SDV and how it is going to help us. Now let's start understanding the automotive OS and then the value stream that is analyzed or realized using the automotive OS. Automotive OS is nothing different. It is just a complex, just a software which abstracts all your complex bottom lines, hardware, right? We will give you an API. You just try to analyze your own system, laptop. You have on the motherboard, there are a lot of hardware that is sitting in there. Do you really care about it? All that you need is those Linux or Windows environment, which is abstracted. You just start working on your building application. So automotive OS will bring in that kind of empowerment for the application developers, where the complex hardware is going to be abstracted. There will be standard APIs, and then the forum, the group of OEMs, the group of software developers, tier ones, will decide the standardization of these APIs. And then once the APIs are exposed, either on the Linux environment or in Windows environment, the application developer can just use those APIs, not worrying about the underlying hardware. That is one power of the automotive OS. The second that comes up with the automotive OS is managing and supervising and also updates, right? So this will be the backend segment of the automotive OS. So abstraction and then working on the actual applications in the car is live execution. On the backend, throughout the vehicle life cycle, there has to be a option for us to update new feature, manage the new manage software, and then if there are any error cases over the vehicle execution or vehicle lifetime, we need to give up or come up with a predictive failure options or give the predictive failure timelines for the user. We can say based on the data that is available, you are going to run out of your battery in next 6 months, or next 60 kilometers you run out of your fuel, right? So these are all going to happen. I mean, fuel anyway, it is there, you have already used it, but the diagnostics that is underlying we can also predict the failures, and then this needs to be managed. So this has to get into the cloud. There are a lot of AI applications that will run on this and then predict the probable failure or the duration of failures, and that needs to be fed back into the system and dashboard so that the driver gets to know it, right? So these are all the management, software management activities that will happen. And if there are any new updates, you fix a bug that needs to be pushed into the car, so that is a software update. So all this is possible. This will be another dimension of the automotive OS, right? And the last but not the least, it enables an ecosystem by harmonizing the APIs, so which will be standardized across the vehicles. We can easily realize V2X, vehicle to anything, or you can connect, stay connected, and then still work, right? What is there in software automotive OS? Just try to give you the architectural definition. It's, if you look at the architectural diagram, all these segments are already available. There is a middleware, there is core software that runs on the hardware, there are hardware abstractions, MCALs, right? So all this is there. What is changing here is the harmonization. So that is edge enablers. And then the next one that is getting changed is the platform services, which will expose the common APIs for the end users. So this is on the vehicle segment or within the vehicle. And on the cloud, if you look at the right side of the architecture here, you see cloud or on-premises activities that are happening. So this is where I was talking about updating and managing your software. So this will continuously happen. The data is being fed back to the cloud environment, a lot of algorithms that run on the data that is collected. So this is how the automotive OS will look like. So application layer, on the left side, you can see the definitions of each of these areas. Application is any feature that any application that you do, any feature that you develop is an application. Platform services are manages functionality across different ECUs. Middleware is comprising of your CAN, diagnostics, memory model, all this is middleware. And then there is a core software which actually sits on the SOCs. We call it as DSP for those SOCs. And IMCAL that comes along with it, right? So this is the basic architecture of automotive OS, which will look like. And today, my partner from Continental has gone one step ahead, showing the next level of architecture, how it looks in AUTOSAR layered architecture pattern, right? So you have to see, it is nothing different. He has tried to add in more blocks there with each of those AUTOSAR layers, how it looks like. Yeah. Then final thought on the value. More than 200 million lines of code that is getting in software defined vehicle. 80% of the bugs can be discovered in the virtual environment before even the actual ECU is available. And then unified software architecture across vehicles, across different platforms, abstracting the complete architecture or complete complexity of the hardware which lies underneath. So this is the value of an automotive OS. No, I was trying to analyze this value stream. what is in it for, what is the value that is generated based on the SDVs and automotive OS, right? So there is customer delight, there is cloud first framework, virtualization, automotive OS, software life cycle management, and digital life experience. This is how the value stream looks like. You're adding a cloud-based solution. You're bringing in the harmonization using the automotive OS concepts. You're trying to manage the software over a period of time. That's how you're creating the digital experience for the customer. And once the digital experience are fed to the end user, there is a delight. This is the complete value stream, right? Now, let's talk about automotive OS in a nutshell. It's a small modular software abstracting the complex hardware that is underlying and giving you a common APIs to use to develop your software. Now, what are the technologies that is needed or that would be available in the automotive OS? It's nothing new. All that is available but harmonized. We will have the AUTOSAR, whether it is classic or adaptive AUTOSAR. We will have the real-time operating systems, both OSEC Core, QMOS, and the safety OSs. We will also come in with Linux environment, the Android environment, and then there will be hypervisors to simulate the environments and safety real cases. There will be cryptography for cybersecurity attacks. Since we are going into a wider segment now, there is a chance, the high probability of cybersecurity attacks. So the safety within the vehicle software needs to enhance. So there will be a lot of cryptography algorithms that will come into picture, and also intrusion detections, software defined network update coordinations, health and state of the management. These are all the management topics. How do you manage your vehicle? So right now, you take your vehicle to a diagnostic center or service center, and then they run the diagnostic tool. But now those features, those applications, we can try building and then giving it on top of the dashboard, right? So all this health monitoring of your vehicle can now be a feature which you can visualize on your dashboard. Based on the status, you can take the corrective actions. And going beyond, some of the cases where we detect a possible failure, we could also, on the cloud side, we could also have a proactive, preemptive corrections and then configure the vehicle on fly so that the hazards that could cause on the road can be avoided. And then we can advise the user for a safe return and then get the vehicle to the service station for repair. So till such cases, we can add the management applications into the automotive OS, right? So what is available right now, AUTOSAR, classic AUTOSAR, safety OS, MCALs, all this is there. On top of it, we will add some cryptography, some harmonizations, and then a lot of management applications with exposing the standard APIs for the end user to develop their application. So this is how the future of automotive OS would look like. It could change as we progress, evolve. Definitely it will evolve. This is the point where we have started with. These are the thought through processes that are thoughts that are going through. It will continue to evolve. And then what is the output or outcome of this automotive OS concept in itself is it's going to be a unified build environment, right? So all of us can start working, try building our applications using common cloud-based build environments. And then between vehicle to vehicle, there is harmonization. So whatever applications you're developing on one vehicle, we'll try and understand the components or the parameters on the other vehicles. It will be seamless transfer of data between vehicles. So with the harmonization that is coming in. And then the other segment that will most of us did not touch when we were discussing SDV is we are trying to bring in the synergy between the global partners here, not just automotive segment, but also we are trying to bring in a synergy between the IT segment, the infrastructure segments, right? There are a lot of regulations that are associated with each of these segments on their own. Vehicles, each of the automotive segments have their own guidelines, regulations by the governments, local authorities, and regional regulations are different from one country to another country. Likewise, when we go for an electronic device, there are regulations on the electronic devices by the governments on different regions again. So each of these segments are coming together now. So how do we harmonize on these regulations, the standards that we want to build? Today we talk about AUTOSAR. AUTOSAR is purely an automotive segment. We talk about RESTful APIs, redfish, bluefish, something that exists in enterprise segment. HP servers or Dell servers follow those standards, right? Now, when IT and automotive are coming together, what would be the new standard? Right? So that is how we will evolve. We will come up with a global standard of manufacturing the vehicles. Software lifecycle management, I just spoke about in detail. So it is maintain, update, and reuse. Maintain, you are fixing bugs. You want to flash it, you don't have to take your vehicle. It will be auto flashed with your scheduled timeline. There will be updates, any new features that get added, any new apps that are getting developed, that will be available for you to use on a subscription mode. And then there could be also an option for us to reuse the parameters that are running in between, or the fail-safe environments that needs to be created using the actual parameters that are seen on the diagnostic stack, right? And then reusing those segments. So this is how the life cycle management will happen through the automotive segment. And then we talked about the cloud, bringing in the cloud partners here. So cloud first, workflow, virtualization, all this is being talked about, everybody is talking. So the build environment will be on the cloud, the test environment will be on the cloud, and then there will be virtual ECUs. You need not wait for the ECU to be manufactured and then you try developing your software on top of it and test it, which consumes huge time. The virtual ECUs will be pin-to-pin compatible. What we can, there will be parity between the cloud-based ECU and actual target. It means they will resemble one another. Where if you do it on virtual ECU, it is as good as doing it on the actual ECU. So this way you don't have to wait for the ECU to be actually produced first. You can start developing, and then CI, continuous integration, continuous deployment, all continuous testing, CI, CD, CD. These are the buzzwords that we have been hearing. And then this is almost reality in some cases, right? So this will also be possible with the cloud first workflow. And then what will be the output of this? What is the benefit that we will get? Around 80% of the development we can do in a virtual environment without needing an actual ECU. We can go 10 times faster to the market. New features, new vehicle variants can come 10 times faster. And 24 hours availability of services, monitoring, and then fail-safe environment creations. These are all possible with the CloudForce. This is another value that will be generated when we move into an SDV environment. Digital life experience, like we mentioned, there will be a lot of customizations that will come into picture. There will be a full digital 3D settings that you can see on your dashboard. You can configure based on your needs. The vehicle features are getting added or disabled, right? So there is pillar to pillar adjustments. There is digital mirror. There are a lot of features that will come, right? I am just curious how this application environment will benefit out of this. And lot of digital experience that you can see. With all this, we will have to create that wow factor in the customer. That is the whole business intent in moving in from a regular software development trend towards the software defined vehicle. Now, to do this, what we need an ecosystem. It is not a game of a single partner here, single player. It has to be a team player. It has to be a team player. We need OEMs. We need the tier 1s, tier 2s, software manufacturers. All of us will have to come in, pull in our ideas, pull in our contribution, and make the software defined vehicle a reality. And this will happen. This is the need of the hour. Yes, it is having so much of benefits. And this is the need of hour. It's just that we need to create this ecosystem. And today only we have heard about 2 such initiatives, one with Renault and another with Ford. Renault and KPIT, Google, and AWS, Ford, Continental, AWS. So this is happening. And over a period of time, we will see each OEMs might start with their own small SDV and ecosystem, but at the end of the day, we will have to have a common ecosystem which will enable each one of us to contribute to the production of vehicles, right? So on this note, Electrobit has utilized this activity, this idea, and then we have a product already available, which is EV Carbos Linux. We have built it on top of Ubuntu. It's a Linux environment. Okay. What was the goal here again? To bridge the gap between the rapidly evolving open source world and the automotive industry. With non-proprietary, which is going to be non-proprietary, means it is going to be open source, which is qualified. All open sources, there are lot of free RTOSs available. We can use it, but there is no guarantee of qualification that is done. So this Carbos Linux is qualified 100% with safety standards, with automotive standards. And then there is this is going to be maintained with a dedicated effort, right? And then so since it is going to be open source, each one of you can take benefit from this. We enable to build a strong foundation of creating the automotive software to accelerate your software application development. And what is the objective that we want to achieve through EV Carbos Linux is fast project startups. Foster the new startups with projects that can be applications that can be developed, and then faster development activities, come to the market quicker with new features, make that differentiation, and then create the innovation cycle or ignite the innovation cycle through this open source, with which the features or the applications that get into a car makes a difference, and then that creates a wow factor with the customer, and customer is delighted. At the end, each one of us are the winners here. As developers, we are winners. As an end user, I am the winner because I am getting multiple features over the period. As an OEM, I am winner because there's a lot of software that gets developed with contributions, and I'm going to market at a rapid phase. And also there are other players who are getting into the automotive segment like Google, AWS, who are in IT segment all these days. They are getting benefited. And when there is huge data that is available, there are a whole lot of institutions that will be benefited, be it insurance, be it the service providers, right? All these segments will also be benefited. This is EB Linux Carbos for you. Please, this is available on Electrobit website. You can take a look at it and then play with it, right? So that's end of my speech, and now I'll open it for questions if you have any.
Is the easy for and the auto per se does not allow open source or free art based OS part of their development. So then how does EB Carbos come?
Yeah, AutoSAR has a standard. I mean, being a standard, we want to ensure what is AutoSAR for me. AutoSAR is a standard that we want to create, where there is a harmonization, we can plug and play different vendor SOCs. At the same time, there is a necessity for us to maintain the hygiene or sanity of the software that is developed, which is safe, which is valued, which is tested. Now, all this is already fulfilled. When I was speaking about the Linux Carbos, it is qualified software, it is safety standard qualified, and it is continuously maintained software. So we are complying with the guidelines that are suggested by the AutoSAR. So there is no question that no challenge, or I don't see an issue in making it an open source.
Open source OS cannot be used for. It just needs to be qualified.
Yes.
And any organization can go and get this qualification, and anybody can get here.
Yes, definitely.
Because until EB was given, there was a lot of perception that I have to buy the OS from because it can't be open source.
No.
So,
yes.
so
no,
I cannot use a POSIX open source OS. Because who's qualifying it?
Yes, the whole objective behind this was there are safety guidelines, regulations by the government. The software application that gets onto the laptop is different than the software that gets onto the vehicle. There are a lot of regulations that needs to be adhered to. And if I take up free autos, I'm not sure will that qualify all those certifications, all those tests. But there are certain players like Electrobit or Vector who are working towards it. They are putting in a lot of effort to qualify those and then fulfill those requirements. That was the safe mindset that was created, that okay, let's go for here, get it. Now if it is open source, which again we are ensuring that it is promising that it is going to be qualified, maintained software, and also we are exposing it for each of the developers sitting around the world to contribute.
So I understand now you can take EB Carbos, put it on Raspberry Pi, and then also go ahead and try to create an adaptive AutoSAR use case and then still demonstrate.
Yes, definitely. Both. It is both classic as well as adaptive. So whichever segment here.
Classic we can come back to a stack.
Yes.
In adaptive, we are still open to develop a stack.
Correct. I say once the automotive OS is harmonized, we will never have to look at, or the whole objective of automotive OS is to abstract the complex hardware that is underlying. So once that is fully achieved, I think it's an open playground for any one of us. Whether we want to play applications in classic segment or in adaptive segment, it is up to us.
Give a little more in detail about the middleware and platform differentiation.
Yeah, middleware and platform differentiation. So for right now, when there is a middleware which is standard according to the AutoSAR, right? And there is also, if you talk about different controllers that we do, right? So we will have to port it. It's not the same software that can run immediately on the different controllers. So it needs to be ported. And for each of the SOCs, we are porting it and then creating a binary output. Now, with automotive OS coming into picture, we are trying to create a wrapper or the middle layer, which will try to abstract this. There will, for example, if you take Java as an SDK, it doesn't differentiate the hardware underlying, whether it is the Linux OS or Windows OS. How is it possible? It is possible because there are different parameters that are associated with Windows or Linux. So likewise, different controllers have their own parameters, be it clock frequency, be it interrupts, be it memory segment. So this is available in the data sheets that are available. Now, can I try a system where to see this underlying data parameters based on the controller ID that is available, and then abstract it from completely getting ported every time? That is how the platform independence will come in.
So what is anything on top of MCAL becomes?
Yes.
MCAL is that common API that lets me connect to anything below.
Yes.
But once I'm above the MCAL layer, then it becomes a middleware.
Middleware, yes. And then whole of this is part of your automotive OS, which will be bundled again together. Right? So for end user who is trying to develop an application, he doesn't have to worry about what is in between that, between the hardware and your application layer. Just focus on the features that you want to develop.
And in the layered warehouse, you have a BSP, and on top of it, you have, if I want to run hypervisor, how does the architecture?
So this was here already. I'm not sure if you are able to see this. One. Yeah. So if you look at this, there is common hardware that is underlying, and on top of it, there is scalable hardware platform. So hardware abstraction and variant management of the hardware will come in picture here. The green one, that is just the starting point of your automotive OS. That is where the actual abstraction layer is getting built. And at the bottom line, there are hardware which is serving the in-vehicle execution and cloud executions. So different zones different ports we can use for different functionalities. And then middleware is our regular CAN stack, communication stack, and then diagnostic stacks, the memory monitoring. All this is middleware. And then on top of it, the platform services, when we are creating those APIs, which can be exposed to the user to use to develop their application. This is something that will be harmonized. So for example, if I'm doing it on Infineon controller, current APIs, we will configure it through your RTE segment now. So we are configuring it differently. Similarly, when I go into Cortex-M, I do it differently, right? So this is something that we can build a wrapper, which will be able to harmonize the configuration across. So giving us this standard API. So all that I need is a COM communication or CAN communication. I'll just write an API, feed that data buffer. So how do I configure it on a controller can be harmonized here with this layer that is coming in. That is edge enabler. So these are the two segments that will be evolving in the current setup. If you say it's a microcontroller, then there is MCAL, there is middleware, and then RT configuration, you do it. This is the existing setup. Now we are trying to bring in those two segments where I'm trying to create an environment where I can be platform independent at the bottom line, and I can also abstract or make the user free from configuring it differently on different platforms. So commonalities, harmonizations, that will be that intelligence will be built in. How difficult is this for India? Not sure. I'll get back to you on this, definitely. Are there any questions on the chat?
Umesh, you mentioned that. Hello, hello.
Partial networking in conventional cars continue in the streets. Will partial networking, under the partial networking in conventional cars continue in the streets.
Yes, the ways we are not taking away any of the existing functionalities or features. We will try to harmonize. Yes, if in case of harmonization, certain things need to be done differently, yes, we will do it. But at the same time, we would not want to suppress the feasibilities or features that are already available.
On the low higher in automotive OS, being worked in the streets.
Yes, oil is something that is an interface. Again, this is going to be a specific to OSEC segment, and then when we want to move into a generic harmonizing standards, yes, this will come in for a change.
Yes, available for SDBs also.
It is just evolving. Already we see a lot of build environments that are created. There are certain virtual issues we have seen. So as of now, yes, it is under development. It will come into picture soon. Okay. All right. So with that, thank you very much for your patient hearing. Who we are connected? We are connected. No, no, we are connected. We are connected. No, people that are getting late. It is. People on the call, are you able to still hear us?
Can you hear us? Vishma, can you hear us? Yeah, thank you.
Yeah.
Yeah. Okay. So thank you, Umesh sir. It was really a pleasure and honor to have you here. It was a very insightful talk on automotive operating system, especially with the fact that these terminologies are quite confusing from a general perspective. SDV and then automotive was what is the difference between real-time operating systems? What are these platforms and all those things? I think you have given us a very detailed account and a lot of insights on those things. Thank you so much for your time, for coming all the way from Bangalore and having entertained us with a very beautiful and very thought-provoking speech. I'll take this honor of presenting Umesh a small token of appreciation. That's in this.
Just presenting this with a motive that you go back in trouble.
Definitely. Yeah. Thank you. So we come to the last speaker for the day. The last speaker for the day is a very young, dynamic, and passionate engineer, Kunal. So Kunal is part. I would. Yeah. Yeah. I think it got disconnected. Can you check please?
Okay. Come on in.
Hello. Is my voice coming on Zoom? Zoom is working? Yeah. Before we proceed to the last speaker, can I invite Arthur from
Hello. Karthik, none of us are able to hear.
Hello, Kunal. We are not unable to hear voice from your side.
Should I start? So there are 5 domains. So you can think of any system, anything which you can see in a car, and you will fall in one of these 5 categories. So this will give you an understanding. Okay, this part of car is responsible for this part of system. This part of car is responsible for these kind of electronic systems and components. We'll give you just one line of briefer for each of.
Hello, Kunal. It's better you start from the first again because we were not able to hear anything until now. And also,
Okay.
you are sharing the wrong screen. You're not sharing the presentation screen, but the notes screen.
Okay, wait.
Yeah.
Is it? Can you see the first screen now?
Yeah, but you are sharing the notes screen, not the presentation screen.
Just a second.
This is fine now.
Is it fine now?
Yes.
Okay.
No, you need to switch the screen. Whatever
Yeah.
sharing, the other screen you need to share. Because you are sharing the presentation one. That's what is the next slide and notes and kind of. I think you have 2 screens, right? You need to share the other screen.
No, I have only seen the screen. Let me share it again.
Okay.
Is it better now?
Yeah, yes.
I think when
Okay,
you put
so
it,
let me start the PPT again. So
Kunal,
the topic of the talk is on the functional domain and E by E architecture in automotive. So basically the idea behind is like since morning we are being hearing so much about automotive technologies. And now the thing comes up that there are many new futuristic technologies being coming in our car. But the biggest transition which we can see since last couple of years and last 5 to 10 years is the transition from mechanical systems to the electronics and electrical systems in a car. Earlier, cars used to be much of kind of like a mechanical transition, full of mechanical systems. But now the integration of electronics, integration of software in a car, integration of electrical components in a car, integration of semiconductor ICs and these things has made the automotive industry one of the largest consumer of the electronics, of the semiconductors from mechanical part. And this regularization has made the strides in electronic industry very much. The strides are so much that when we are in an average car, the modern vehicles which you can see of BMW, Audi, these vehicles, these are having about 1 lakh line of code running in them. So you can imagine the amount of software, amount of C program that is being running in a car. The more than thousands and thousands of electronic and electrical subsystems having microcontrollers, microprocessors, registers, capacitors, these things are integrated in a vehicle. So the dependency of electronic industry and electrical industry and software in automotive is being increasing very much and will be evolving more and more in upcoming time. And this makes the integration of different electronic systems in a car more easily and in a car more wide. Like in a car, you can see number of features: automotive seat adjustment, wireless keys. There are proper whole infotainment system where we can have proper app stores also, play games also, listen to music. So what are these things? These are basically integration of different electronic systems in a car.
Yeah, hi Kunal. Sorry for the interruption. Can you just maximize the screen?
Maximize the screen. Like, is it not showing you on the screen?
Yeah, it is showing, but beside that, next slide it is coming.
It is the presentation assistance screen, Kunal. That's what I was asking. You might have two screens, and the second screen might have got actually the screen, the PPS mode, the presentation mode, whereas this one is for presenter to see the next slide and prepare. So you need to share the other screen.
No, it's good.
Yeah, this is better.
Yeah, just leave it as it is, Kunal. You can use
Yeah,
it.
that's better. You can actually remove this side window. Then this itself is enough. And collapse the ribbon and remove the side one, the outline. That itself is fine, because the other one is coming with very small window.
Is it fine now or is it still?
Yeah, this is fine.
Yeah, this is fine. We can continue this way.
Stop sharing vision.
Yes. Is it fine now? Is it still same?
Still
No.
same. Maybe you share the the presentation itself. That is okay.
Kunal, just go to the
Come
display
back.
settings and switch screens. That's it. On the top.
Go to the display settings and change it.
Go to the display settings and switch screens. Yeah.
No, otherwise cross that next slide.
Can we do that? I don't think so.
Next slide you can cross, Kunal. Right side. You can cross it.
I don't think it's possible because it's for the presenter's assistance, right?
Yes.
So the other slide, other screen where this presentation is going should be shared. I don't know.
I think you just have to do it in the display settings. On the top,
Display settings on the top, just
Yeah.
switch the settings. Yeah.
Yeah.
I think this is better. Let me show the presentation like this only.
Yeah, the main original presentation should be also fine.
Yeah.
Yeah, you can go in this way only. Don't do any changes.
Okay. Okay.
Yeah. No, don't do that. Don't do that.
Like this one. Okay. So I hope now everything works out. So, okay. We are basically like as if now covered 5 slides in which basically I brief about the transition in automotive industry, use of electronics, software, electrical components in automotive industry, and how we can categorize different electrical electronic components, subsystems in an automotive vehicle. So for that, there is a terminology by the name of functional domain. So there are different functional domains in a vehicle according to which we can categorize every electronic or electrical system which you can see in vehicle. You step into a car, you see a electronic electrical system, you can categorize in one of the 5 domains which are listed over here. Powertrain, chassis domain, body control domain, HMI domain, and telematics domain. So as its name says, powertrain domain, it is the domain that actually drives your vehicle. It actually makes your vehicle into the motion. So kind of like systems like of engine, systems like of transmission and all these subsidiary components. All these would be lying in the powertrain domain, the BMS, and these lie and could come in the powertrain domain because these actually make your vehicle into the motion. If there is no powertrain domain, your vehicle would not be running, and all the things apart from powertrain are just extra features to make your vehicle more comfort and futuristic. Then comes the chase body control domain, which doesn't belong to the, it has no role on the vehicle dynamics, but it makes role on the vehicle appearance, luxury things, comfort in the vehicle, kind of like seats are there, rear view mirrors, interior lighting, all these things, seat adjustments, more and more comfort on the vehicle. All these comes in the wiper is there. All these things comes in the body and control domain. Then comes the chassis domain, which like the chassis domain and powertrain are kind of like the heart of the automotive vehicle. Powertrain runs your vehicle, chassis domain interacts with the road, wheels, all these wheels and how the wheels will be interacting with the road. That so that skidding doesn't comes up in the vehicle. It is safe and it is you make the vehicle in high speed and you make the brake automatic immediately so vehicle don't skid. So all these components come in chassis domain. Then comes the HMI domain. Now, as there is a powertrain which is having an engine. Now, what is the engine health? How the engine is behaving? So that all information to the driver, to the vehicle repair person is communicated via HMI domain. The human machine interface, basically the machine and the parts which are driving the vehicle. So how the vehicle is behaving, that all information is given via HMI domain. So in this you can see the infotainment where we can see the cameras, front camera and back camera. So how the what is in the back of your car and parking cameras. So all these is come in the HMI domain. Then there are displays, monitor displays, which shows like in the cars now there are many this graphical infotainment systems that okay this is the music playing in your car, this is the directions you want to go. So the information is being passed to the driver, to the passengers. And then the final domain, which comes the telematics domain, which interacts with the vehicle outside, like the any other communication outside the vehicle. GPS systems are there. Okay, Bluetooth systems are there in it. So these are systems which are communicating outside the vehicle. As sir was telling about the vehicle to vehicle communication, vehicle to infrastructure communication. So all these things comes in the telematics domain, when which the communication or the things are happening outside the vehicle. So now you can see there are so many electronic systems in a car. There is a car headlights, or the this and ABS systems are there. So now another big challenge comes in: how do we arrange these systems? Now car is small as compared, like if we analyze and calculate the wiring which is used to connect these systems, it is more than 4 to 2 kilometers of in length, which is being wired around the car. So now how should we arrange these different electronic systems? Because let's say there is a node A which is having a this vehicle motion monitoring system, which will monitoring the vehicle. If any impact on the vehicle will come, correspondingly, or the seat, the this the car backlight gets on, or the SOS alarm is goes on. So how do we arrange different these electronic components in a vehicle? So here comes the concept of E by E architecture. So E by E architecture is basically the design and architecture and arrangement of these electronic subsystems. So as in the previous slide, sir was mentioning about the types of EVARV architecture: flat architecture, domain architecture, and zonal architecture. So flat architecture is the one which is being used as if now, mostly 2022 and previous to it, which is a simple system in which what we used to do, just integrate ECUs over and over. Okay, we need a feature of automotive seat adjustment. So we will take a ECU which will be having a servo motor, connect a servo motor to it and give a push button to it to control it. Okay, now we want to have some vehicle motion monitoring system. We will connect the gyroscope sensors and those with it. Measurements would be given and correspondingly. So according to the feature, we add on the sensors and modules to the ECUs, and then ECUs to the connect with each other. But this approach was not so optimized. Why so? Because as I am mentioning, you can see in the photo, there are so many electronic systems which are being.
there is a 1C system which is at the front of the car. Okay, now that has to be communicated with the back of the car. Now front of the car system, which is there node A, is also need to monitor some components which are in the middle of the car. So wiring, how will this communication be happening? How will these arrangements be happening? This becomes quite cumbersome when we are expanding the flat architecture, because there is no such architecture symmetry or this thing in the flat architecture. So here comes the domain architecture. So the in architecture, can you give this back? That one. Yeah. So now after the flat architecture comes the domain architecture. So as I was telling about different domains in a vehicle. So now what happens is what engineers and companies started thinking of, we will design the vehicle according to the different domains. There is powertrain in a vehicle. Okay. So what we will do, we will connect all the powertrain related components to the one domain controller, and all the body control related components to the one body control controller. And then we will be communicating via these main domain controller or the body control domain to powertrain domain controller to another HMI domain controller with each other. So this will reduce your wiring. So if let's say there is a some component like engine is in powertrain. Now we need to transmit the engine health parameters to the car infotainment. So engine will not be directly communicating with the LCD screens with the screen shown in your car. Engine will be sending data to the powertrain domain controller, and from there it will be sending to the HMI controller, and from there it will go to the screen. So you can see there are nodes. Communication would be happening via endpoints. So this makes your architecture quite symmetrical, quite easy to understand, and quite easy to portable. If you want to change, okay, now I need to change the engine sensor. So I just need to change that sensor. All other connection and wiring would remain same. So this is the domain architecture in which the domains, the car design is divided according to the different domains, different components of the vehicle. So there are mainly 5 domains, as I have told. The body and the HMI body and control domain, telematics domain, chassis domain, and telematics. So all these domains are having their own ECU nodes, and these domains will be communicating with each other for some intercommunication, for some sending data from one domain to another domain. But in this domain also there were certain challenges, because that we have to use very large amount of sensor, the large amount of microcontrollers for every small domain, for every, like let's say in a body and control domain. So we are having seat adjustment for front seats, we are having seat adjustments for back seats, and then on the corresponding we have wipers, we are controlling wipers. So for every node there would be a different microcontroller. So there is very large quantity and large dependency on the microcontrollers. So if there is not even a single microcontroller not available, our whole car productions can be stopped. Okay, and that's what is happening in the happened in the COVID time. And then here comes the zonal architecture. Now zonal architecture, what does it do? It divides the car according to the location. So now if there is a body and control domain, so now seats are there, the 2 seats are in the front and wipers are also in the front. So we will be having a location yeah, we will be having a zonal gateway which will be handling all the electrical electronic parts of the front of the vehicle. And in that zonal gateway, there can be different domains or different parts of the domain. So let's say in the front of the car there is engine also. In the front of the car there are components of seats and wipers. In the front of the car there is front wheel also. So all these will be in a zonal gateway or zonal location 1. Now from this location to another location, to the diagonal location, we'll be having direct communication via zonal gateway, then zonal gateway, and then central gateway, and then the zonal gateway. So basically kind of like the car is basically having now being categorized according to the different locations, and each location is having different components of different domains. So it becomes more symmetrical, more portable, and more futuristic, more easy to integrate new systems in our car. So this is zonal gateway. So yeah, this is very much it, the things which I want to tell about the today's topic, on which I am really zonal domain and the EY architecture. And now telling about me and about my platform. So Get to Byte is the platform which is there, which I am representing for here, which is basically a semiconductor hardware manufacturing and software development company. So basically what need and what market segment we categorized is that there are so many semiconductor chips around us, but the hardware solutions and software solutions around them are pretty less. Simultaneously, as I have told about the zonal and domain architecture and different domains in a car. Now, to develop such technologies, to develop such systems, we need to have the powerful microcontrollers, powerful hardware tools around it. So we are basically into that only. We provide different evaluation kits, development boards to the industrial microcontrollers, which are coming up, which are basically on the which supports such upcoming technologies to be integrated in automotive, in drones, in medicals, industrial automation, and these things. Simultaneously, we also have training kits, the with the ANCIT, we have collaborated for it, training courses which we are developing for the two new technologies, so that people can get aware of it, can upskill themselves from corporate trainings to the professional working professionals to the students and colleges. So these are latest products, electronics version 1 and Autoboard version 1. So electronics version 2. So as I have stated, there are 5 domains: powertrain, body domain, chassis control, telematics, and HMI. So electronics version 2 board is being designed for mainly powertrain and chassis domain, so that people or the students can get a feel of how to make such, how to work on such projects, how to work on such things. And Autoboard, the electronics version 2 board is for powertrain and body control. It also have many automotive standard-based security systems, and it's a cryptographic engine, and it is supported of automotive safety standards. It has number of onboard automotive peripherals for making your automotive DIY projects at a college level or at your own. And it is available at right now, and you can buy it from the Electronics Infra website. And if you buy before till Monday, we are having a discount of thousand rupees of buying more than 2 or equivalent to 2 boards. Another board that will be coming in the March is the Autoboard version 2, that would be for the zonal and domain controller specific applications, as I have told in my in the PPT. So using these boards, you can make your zonal gateways, your domain controller specific applications, get an hands-on on them. Okay, what is like you can make your own small ECU nodes using the electronics version 2, and then connect all those electronics version 2 with the Autoboard version 2 for your as a zonal gateway or as a domain gateway. And we are Get to Byte, as I have told, it started by a YouTube channel, and we have a website where we share content, blogs, training related contents, and technical videos on all these things. So yeah, you guys can reach out to me at my LinkedIn profile or my website or at the YouTube channel and LinkedIn and website also. And yeah, so yeah, that's all what I would like to conclude with my presentation. If anybody is having any doubts and queries to ask, they can ask right now.
Okay, thank you, Kunal. Thank you so much for your time. It was a very interesting and a very light-weighted session to close the evening after a long technical discussion. Thank you so much for coming and making this event happen. I would like to give a small certificate of appreciation for you. Thank you, Kunal.
On this note, I would like to thank each and every one of you who have made it to this Automotive Tech Day. We hope to meet you all again in our next Automotive Tech Day. Thank you so much for joining us. It is a pleasure hosting all of you.